Hey, what's up, guys? Welcome back to PTS Care Expert and myself, Architect Kumar Kapadia from the city of Surat in Gujarat. And a humble request to all the viewers of this particular video that just thoroughly go through the explanation part before skipping to the main content of the video, that is the modeling part. Learning process is lifetime, and with every batch, I as a tutor also keep updating myself and reforming myself and my modeling skills so that I can deliver and reach out best to you guys. Whenever we start a particular project, modeling of a particular project in Revit, that what we generally do is that we draw the walls and constrain it starting from the base level to the topmost level by adding floors at intermediate level. But have you ever wondered that is that a correct way of modeling? Then the answer is no. Revit is a very technical software and is meant for modeling of the structure following the hierarchy of modeling of elements exactly in the same way a structure is elevated on site, which eventually helps us creating the perfect schedule, okay, and which eventually gives us the perfect quantification and costing of the 3D elements, which I'm not just going to show you today in today's exercise, but if I'm just going to prove you with the help of a couple of examples, wherein if you just see, then this is a simple G+2 structure elevated in Revit, wherein if I just take it to this particular ground floor and if we go to this particular section, then what do you notice is that, let me just take this particular view range a bit far. Then what do you notice that this particular exercise and the structure follows the modeling of the 3D elements in exact precise way, following some hierarchy wherein you see that the structural elements starting from footing to column to beam to floor, and how are all that structural elements joined to the architectural elements to the wall, that is wall with its wrapping layer and its join condition. Fine. For example, if I just talk about this particular wall and if I just select this wall, then you see that it is not elevated starting from base level to directly from top level, but it stops here. Fine. It particularly stops at this particular point, and you see that the base constraint is ground and the top constraint is first floor with a top offset of minus 18 inches. Fine. And then here and another wall, that is the beam wall, has been casted and laid, which is excluding the masonry part, which is not taking into consideration masonry part for this particular beam, but only you have the plaster layer wrap. Okay, and the same thing follows for the entire structure. Okay, you see that this particular drop slab with this inverted beam and this particular floor plate having all the finished layers, brick beds, sand bedding, mortar, and the finished flooring and everything. Fine. But what is the need of following this particular process and modeling a particular structure in Revit with such precision? Fine. So this will explain you that. I'll just take you to this particular another example. Fine. Wherein you have a simple cube of 3 cross 3, and I've just rounded up the figures in order to prove you. As I said that I'll not only show you, but even I'll prove you that it gives exact quantification. Fine. So if I just go to this particular structure, and right now we are not going to take into consideration the structure part for now, but just to prove you guys, what I'll do is that with this particular simple structure, 3 cross 3, fine. If I just go to this particular schedule and quantities, and if I just go to the particular wall schedule, then what do you see? What do you notice? That the two walls are exactly reading 3.52. Okay, so its area is 3.52 cross 3, that is 10.56, and two walls are exactly reading 3.30, that is 3 cross 3, that is 9 meters square. Fine. So with that, what you can do is that you can exactly have, on the basis of cost factor, you can exactly have the cost of masonry with the number of bricks. Fine. Not only that, if I just go to this multi-category takeoff, then you can exactly have the area, the cost of plaster with the material cost. You can just have the cost of plaster added to this particular wall. But this particular thing is more of relevant for that another options which I deleted, okay, which are not going to take into consideration the masonry part and just the layer of plaster that has been wrapped to the masonry. Okay, so the point is that if you cannot model with this precision in Revit, then there is no point of using Revit for your modeling purpose. Fine. And following this same process and same modeling skills, we are today in Revit going to elevate this simple G+2 structure, strictly following the modeling skills and the rules. Okay, so this is going to be very informative video. Watch the entire video till the end. And if you think that this video was worth, then kindly enroll for this course Revit BIM, which is the combo of architecture plus structure plus MEP. The next batch of which is going to start from next Thursday, that is 14th of March. Okay, so herein I'll just acquaint you to this particular structure. So thereby, let me just acquaint you to the various features and functionalities of this particular project, which is a treasure of information model pertaining to a particular building with LOD, that is the level of detail 400, which only takes into account the architectural segment, and a bit of structure has been incorporated, but it doesn't take into consideration the MEP part. Okay, so as I've been always saying that I just showed you with that two simple small examples that how efficiently we can model the 3D elements in Revit. So that was pertaining to the 3D interface. But as I've been always saying that Revit is not only about the modeling of the 3D interface, but it very prominently and efficiently does model the 2D interface. Okay, which again has a two bifurcation, wherein one is the creation of sets of drawing, and another is the creation of sets of details which are required for its execution on site. Fine, so this is pertaining to the preparation of various different sets of drawing, wherein this is the site plan. Okay, and this is the presentation drawing of the plinth level. Okay, so what do you notice as that this is reading the area. Fine, the nomenclature is reading the name of that particular area with its square feet. But now if I just take you to this particular working set, plinth level working, then this particular drawing is called the execution drawings, which are used for executions on site, which shows the dimensions, but at the same time it shows the nomenclature of that particular space by horizontal into verticals. Okay, and all the tagging and necessary information, dimensioning and everything has been added. Okay, these are the revisions that is added. Okay, so that is the working set. Then we have several 3D different sets of 3D drawings also, wherein this is the exploded view. Okay, and then coming to the elevation, so these are the presentation elevation. Fine, so you can see that such beautiful presentation is created in Revit, giving the depth that which element is former and which is the later. Fine, so likewise you can create the different sets of drawings. So this is showing the different elevation but using the different realistic skills. Okay, likewise you can also create beautiful sections, informative beautiful sections. So see, these are the sections wherein you can provide all the heights. Okay, and this is also a section. Fine. Okay, now let's go to the area gross plan. That often designers are interested in calculation of space, that which is the circulation, private, services, public and everything. So that is also very efficiently done in Revit, and this floor plan shows the area gross plan of that particular ground floor. Okay, just like that you can also have a graphical schedule of the column. This shows the column starting from the base level and going up to the topmost level. Okay, just like that you can also have the typical details in Revit, but drafting details in Revit, we as a designer are working on AutoCAD for years, and drafting details in Revit, just like AutoCAD, is very time consuming. I'll not say that it's not possible. Revit also provides all the 2D details under the detail items tags. Okay, detail item sector, but drafting details like AutoCAD is very time consuming though. So if there is a flexibility of interpretability between two software, we can just create the drawing in AutoCAD and we can just bring it here, which can be part of the sheet composition, and I'll just show you that in a while. Okay, so that was pertaining to the part 1 of the 2D interface. The another part which involves the creation of information needed for execution for site, that is the schedule part, wherein you see that this is the door schedule. Okay, which says that there are total number of 18 doors, and you have the bifurcation floor wise also with all this particular details, that is width, thickness, height, its description, the fire rating, manufacturer costs, and likewise you can add innumerable information, lots of information, whatever you want to this particular door. the 3D elements. Okay, just like that, you can also create this particular window schedule. Okay, cost factor has also been added here. Okay, and the cost factor is added here also. Yeah, fine, that's okay. Now I'll just go to the particular floor schedule. Okay, so what does it gives? It gives the quantity of RCC, that is the different types of slab, various different types of slab that are going to be get casted with RCC in on your particular project. But what about the material? Since we know that a particular RCC floor, unfinished floor, has several layers of finished materials to that. Okay, so this particular thing, we can have a material takeoff, and with that you have all the materials defined in your project floor wise. With that you can also define the costing and whatever detail you want to add that. But let's say that of this you just want to segregate the amount of mortar that has been used in that particular finished floor. Okay, then that also you can have, then this particular schedule with that particular filter command, you can just filter out a particular material and its area and its cost. Okay, so the same thing applies to the wall, wherein you see that this is going to calculate the cost of masonry work, the area and the length and the cost of the masonry wall of the 9-inch 2 brick thick 9-inch wall which are going to be built in your project. But I have just filtered it out. If I just say that I want all the walls which are going to be built in my project, then it will give you all the walls and all the details of that particular different types of walls that are going to be used in the particular project. This is compound walls, load bearing wall, okay, stone wall, and lot the different types of walls. Okay, I'll just click undo, and this is how we can bifurcate different walls. And also we can have different materials that are going to be used in the which are going to be applied on that particular masonry work, and the finished layers of the material that is going to be applied on the different types of walls. Fine. Okay, so these are the different types of material which I have defined for that particular different types of walls, of which we can just bifurcate the amount of plaster that is going to be used for the construction of 9-inch 2 brick thick masonry wall. Okay, the quantity of plaster. Fine. And in the end we could have this particular beautiful sheet composition. Of course, the designer will never issue the sheet in this way, but this is just to show you that drawings of different disciplines and different scales can be compiled together like this on in Revit. Okay, just like that, we have this particular sections, then we have this elevations. Okay, and we have a couple of details. Okay, so you see that the AutoCAD plan can also be part of this particular sheet. What we just need to do is that filter the layers and change its line thickness and color as per our requirement. Fine. So this was pertaining to this particular entire project, and we today in Revit are going to model. Also we can switch between various options. You can say that we have modeled a different options, and you can show the different options to your particular client. Okay, not only the 3D part, but if I just go to the particular floor plan, then what you see that this is pertaining to the configuration. This particular sitting furniture configuration is pertaining to option A. Okay, that is first option. And if you want another layout or another option, that also can be done. And with this I'll just switch to the another option. Fine, so this is another option. So that pertains to both the furniture layout also and to 3D also. Fine. So for this exercise, we are just going to take into consideration this particular option, which we are going to perfectly model from scratch, from footing level, with all its details and its joint condition and perfect precision. Okay, so let's start. So let's go to file and new, and let's open a fresh new project template. While going to browse and say that English Imperial, since we are going to use Imperial system for this exercise, and default architectural project, and just click OK. Now, the first step, what I'm going to do is that since we have a lot of details established in this particular project, what I'm going to use the features and functions of Revit to transfer the project standards with which we can easily concentrate and work much more on the modeling part, and we don't end up wasting time on creating the families and the custom customization we do to the 3D elements. Okay, so what I'm going to do, I'm just going to this new project and say that manage, and say that where is it? Yeah, transfer project standards, and copy from live project March 24 batch. Yes, that's okay. Check none. And I'm just going to navigate to this particular floor types. Then we have this wall types. Then we have materials. Then we have door types, and I'm not sure whether you can copy door types or not. And if not, we will just copy it by the another function. Okay, with this much copied, I'll just say that overwrite. Okay, and it'll just take a bit of time to regenerate. Yeah, that's fine. So that much portion has been copied. So if I just click WA, that is wall. Now, if you just drop down, then what you see is that all the walls from that particular project has been copied. So a lot of time will be saved. Don't worry, I'm going to show you that how to make this particular assembly and how to edit it and how to customize it. Okay. But just to save time, I have copied that particular standards from that particular project. Okay. Next is that I'll just go to this particular project, and again, I'll go to this right elevation, and at the same time I'll just select all of this structural elements which cannot be copied by standards. So here is the new function which I'm going to use. I'm going to say that copy to clipboard. Okay, and with that copy to clipboard we can also select door windows, but that later. I'll just come here level 1 and modify and say that paste align to current view, and okay. So with that, all the structural elements will get copied. Don't worry, I'm just going to show you that how to model this, but I don't want to waste time making those families. Okay, so I'll just select all of this and just delete it because we have everything in this particular project. Next is door windows. So what I'm going to do is that I'll select this SA, not SA, but I will say that override graphics in view by category. And no, sorry, not that. I'll just select this and say that isolate category. Yes, fine, isolate category. And with that selected, what I will do is that again I'll go to this right elevation. I should have selected window also. Let me just press HR, and I will select this window and this door, and I will say that isolate category. Beautiful. And with that, I'll just go to right elevation, and herein I will just say that copy to clipboard, but we don't have walls in that particular project. So what will you host it to? Let's check whether it works, and if it doesn't, then we will copy it later. So herein I'll just go to level 1 and modify and align to current view. Yeah, okay. And I hope that all the 3D elements, door windows have been copied. Let's just check. It'll take a bit of time to regenerate. So yes, can't place elements because couldn't find host. But if we just check DR, that is shortcut of door, then all the doors have been copied from that particular project. And if I just click window, then you see that all the windows have been very beautifully copied. Okay, fine. So now we can concentrate on the modeling part. Fine. So I'm real quick going to go to south elevation, and I'm just going to click LL, and with this pick lines, I'm just going to offset 4 feet and then 2 feet. This I'm going to turn it to minus 18 inches, and then again LL and pick lines, and with the offset of 10 foot, I'm just going to create a couple of levels. Okay, and with that, I'm just going to scale this down a bit so we can visualize this. I'm going to call this footing bottom. Yes, this should be footing top. Okay, and this should be Actually, this should be ground road level 0, 0. And this should not be minus 18 but plus 18 inches. I don't know why did I made that mistake. That's okay. And not even 18 inches, 2 feet. Okay, 2 feet, and that would be plinth level. Plinth. Plinth level. Yeah, fine. And I guess that I need to delete this too. Okay, LL, and with that, LL is the shortcut. Declines 10 feet, and this would be 12 feet, and this would be first floor, terrace floor, and just sorry, too fast. Yes, and LL, the last level, that is the slab top. Okay, perfect. And this would be essentially not the level but the name, first floor. This would be terrace plan. Yes, and this would be slab top. But now let's see that whether that occurs in hierarchy in this particular project browser or not. So we have this level 2, which is of no use. I guess that it should be deleted, and this is not following the order according to the level. The hierarchy is not following. So let me just first go to view, and with that checked on, I'll just go to plan view and floor plan, and plinth level is not there. So I'll just bring that. Then I'll say that structural plans, both of these are not there. And again, I'll say that reflected ceiling plan. Yes, reflected ceiling plan, very important. And all of the levels, consecutive levels, has been made in reflected ceiling plan. We just need to arrange it in perfect order. And with this, let me just check once last. Yeah, see, so plinth level was being created. Okay, so what will we do? We will just go to this browser organization, and I'll just create one new, saying it by level. Right now, just watch the order. It is popping up. So with this, I will just say that going to sorting and grouping and by family and type, and sort by associated level. Just click OK, and I'll just tick this by level and apply and OK. And what do you see is that now it is following the perfect hierarchy according to the levels placed. Okay, so with that, we have created all the levels. Next is that we need to go to the footing top. Fine, and insert and import CAD and desktop, and let's just navigate to the file. You will get the file, don't worry. AutoCAD file मिलेगी आपको 8 March April basics, and this I guess that footing plan and preserve all, and this should be inch, and this positioning should be manual center, and just open. Okay, so with this, we have just imported the AutoCAD plan over here, VG, and I will just turn this footing plan to halftone, apply, and OK. Fine. So with this, now we are going to first create the footing. So the structural consideration says that this are the isolated footing, and this is the combined footing, and this is the continuous raft, this is the step footing, and this particular is the strip footing holding a load bearing structural wall. Okay, all the structural considerations are pretty much basics and conventional, and I might be completely wrong. I may be partially correct or completely wrong, but the only motive is that to show you that how can you model the structural elements in Revit while working on an architectural elements. Okay, and since we have transferred all the structural details through project standards, if I just go to this particular structure, and if I just click this particular isolated footing, then you see that we already have. Let me just save this before I lose it. So herein, if I just go to this rectangular footing, so you see that already that type has been defined, and it is nothing but this the foundation thickness and width and length, and where can you load this particular thing from, that is load family, and just go to RVT libraries English Imperial US, and under that you have this structural columns. Fine, sorry, not columns, and structural foundations, and there you have this all different types of footing from where I have loaded this rectangular footing. Okay, so if I just go to this beam, sorry, not beam, isolated, and we have this 5 foot 6 inches cross 449. So if I just I want to place the level, but yes, in order to visualize that, when you place that, you need to give it a height offset of the thickness given to that particular footing, and with that I'll just place it. Okay, and I'll just modify and align 1 to 2. Okay, and that is how we have created that particular footing. We have placed that footing CO, and I'll just copy it. Okay, and if you just go to 3D, then what do you notice? That that particular footing has been laid at this particular footing top level, but ideally it should go beyond this level. But once we attach the structural columns onto that footing will go in place. Fine. So again, I'll come to this footing top and CO, and I'll just copy it a couple of times, and here I cannot find the snap point. I'll just rotate by pressing space and modify and align. I just align it, and likewise I'll align this footing. Okay, that is how we have placed the, but for this particular 4 footings, I guess that it has lost the connection. So again, I need to press align. Okay, and yes, okay, so that is how we have laid all the isolated footings. Fine. Next is that this combined footing. So again, going to structure and isolated footing, we have that type also been defined, 5/6 cross 12, and that I'll just place. Okay, and modify and align. Just drag it a bit outside. Fine, and just CO, copy it from this point to this point. That's okay. Now we have this raft. Okay, so another type of footing to be laid. All the structural considerations are basic and conventional. It has nothing to do with real practical life, just showing you the modeling process. Structure, and this is that particular slab, foundation slab, structural foundation slab, and you see that 2 feet. This is that particular, and I need to define the boundary line, and again say that the height offset from level should be 2 feet. So that will lay that particular raft. Okay, now we need to create this particular footing by slightly a different way, when I just drop a section and a reference plane, and we are going to use a different method to create this particular step footing, wherein I'm just going to go to architecture and component and model in place and say that structural foundations. Okay, and just name it step footing. Okay, and yeah, fine. So with that, I'm just going to use this extrusion, and extrusion start, the work plane is footing top. From there, I'll just create one extrusion start 0 and extrusion end 3 foot, and I'm just going to give it a material of RCC, which are pertaining to this different other footings also. The same material I'm going to apply, concrete, and yes, concrete cast in place gray. That's fine. Okay, and just say that finish. But with that, I'll just go to I'll say that create and set plane and pick up plane, and pick this particular plane and go to the particular one section, and herein I will just create void sweep. But essentially, first I need to create the profile, sketch the path. So for path, I'll just drop this particular path, that this is the path, and now we will edit the profile. So select profile and edit profile and go to section 1. Okay, so with that, now I'll just drop a line, go 2 feet in this direction, 1 feet down, 1 feet again this direction, 1 feet down, and here is I have completed this particular thing. And if I just finish and finish, then you see that our step footing has been created at that particular designated level. Okay, we just need to move it in place, for which I will just select this particular entire footing and drop it to, but let's first place the columns. Okay, so with that you'll be able to find. So this, now this is a strip footing, so this is again a different type of footing. Fine. So in order to place that footing, you need to host this wall, because those footings will be hosted by walls. So you see, structural foundation wall creates a wall foundation that is hosted by wall. Fine. So this is the strip footing. So we are going to create WA, and I have already created that particular wall. So this is the importance of the project standards. So once established, you can load from project to project. And this is that main wall. load bearing stone wall. And if I just go to apply, edit type, then you see that it has been given the width of 15 inches and the structural stone material has been applied to it. Okay, fine. So what I will do is that I'll just click OK, apply and OK, fine. And I will just create with this particular finish face exterior, saying that the base constraint should be footing top and the top constraint should be first floor. And I'll just create one rectangle. Okay, once that wall created, now we can create that footing, and I've already created that particular wall foundation footing. And from this drop down list I will just select this particular 3 feet 3 cross 2 inches, because if you just measure the width of this, that is 3 foot 3 inches, and its thickness will be essentially 2 feet. That is the thickness of all the footings that have been laid. Okay, so what I'll do is that wall, and with that footing selected, I'll just click the walls 1, 2, 3, and 4. It says that none of the created elements are visible in the floor plan. Footing top view. You want to check the active and blah blah. So what does it mean? That particular footing has been created. Okay, that wall hosting that particular footing. Okay, that has been created. But I guess that its thickness, I guess that will be selected wrong. Okay, so I'll just press SA, and from that I'll just select this 3 cross 3 3 foot 3 inch cross 2 feet. Yeah, that's fine. Okay, now what I'll do is that I'll just go to this front elevation, and here I will but let's first place the columns. Yeah, forgot, sorry. So footing, while coming to footing top, now we are going to host the columns onto this particular footing. So I'll just press wireframe WF. Okay, and with that I'll just say that structural column, in your case it won't have been loaded, so what you can do is that just go to load family, and in US, English Imperial US, and here, just like structural foundations, we have this particular structural columns, from which you can select this concrete column and concrete rectangular column. And I have just loaded that into the project, and I have decided the size, that is 9 cross 18. Fine. So base offset is 6 feet, and the breadth and height is 1 feet 6 inches cross 9 inch. Okay, and instead of depth, these are the instance parameter, they need to turn this to height. Okay, and height up till let's take it up to plinth level for now. Fine. But if I'll just place this, then it says that attached structural foundation will be moved to the bottom of the column. Fine. So that is just what I wanted to show you, that with this structural column hosted, this will footing, this will move in place. But what will you do? Will you individually host all the columns to this particular footing? So the answer is no. I will just delete this, and I'll just press undo first. Fine. And what Revit has this very powerful function, that is grid line. The grid line, this command doesn't limit only up to providing the center line or face line, but the functionality of that is way beyond, and I'll just show you that what it is. So from here in, I'll just copy it from this point to this point, and this point, and this point, and this, and here this orientation. Okay, here I guess that we need to place that, just move it from this point to this center of this. Let's just move it from here to the center of this column. Yeah, fine. And just then again GR, or you can select this grid and copy it from this point to this point. Yeah, fine, perfect. So that is how we have laid the horizontal grids. Now the vertical grids. So I just select this one and CO, copy it from this point to this point, and here this is an alignment, so I guess that we don't need to provide it here, but here we need to provide one. Okay, so I just drag it a bit. Okay, and all of this I'll just drag it to this point, and from this point to outside somewhere. Fine, and I'll just call this A, B, and C. Sorry, C. Okay, now you can just provide a shift line over here, and give the necessary dimension, and also we will have the grid lines over here. But right now I'm just going to show you the purpose of placing this particular grid lines. Okay, so now I will just say that columns, structural column, and 9 cross 18, and with this function say that at grid intersection creates a structural column at the intersection of selected grid lines. Fine, with that selected, what I'll do is that I'll just have a cross window, fine, and finish. So you see that attached structural foundation will be moved to the bottom of the columns. And now for all the footings, the foundation had been moved to a designated level. Okay, wherever not, we will just do the needful. So this is one. So I will just move it, and with this joint checked on, I'll just move it from this point to this point. Yes, okay. And also this step footing. So I just move this base with constraint checked and this joint with constraint unchecked and this joint checked. I'll just move it from this place to this place. Fine. So with that, now if I just go to 3D, oh sorry, not this 3D, but this particular 3D. Then all the footings have been laid. Fine. R enter, and yeah, see, one of this footing has lost its connection. So what we need to do is that we need to go to footing top. We cannot visualize that footing. So let's place one WF footing top, and I guess that this also is not aligned. Modify and align. So this to this. Yes, because it laid the column at grid intersection. Now what we need to do is that we need to align this particular columns properly according to the AutoCAD plan. So herein what I'll do is that I'll select all of this particular columns and just press space. By pressing space, it will flip the direction. And I guess that here we don't have any columns, so I will just delete that, select and delete that. Okay, this 1 and 2 also need to be flipped, and this needs to be positioned here. Okay, also we don't need these 2 columns, so I'll just delete it, and this particular 2 columns I'll just place space and flip the direction. Fine. So with this, now we have created the footing at this particular designated level. Fine. So now we need to move forward, and if I just see it in front elevation, then everything is snapped perfectly, having the same base. Okay, so now coming to this particular plinth level, oh sorry, now coming to this particular ground level, first is that we need to host the AutoCAD plan. Okay, and how to do that particular thing? So I'll just go to this particular footing top, and I'll just press LI, and herein I will just take any of the base point, reference point. Fine. Oh sorry, and delete it, LI, and just draw one line, and from here I will just say that edit work plane and pick a plane, sorry, not pick a plane but edit work plane, and snap it to ground level, ground road level. Fine. So now if I just go to ground road level, so we have a snap point where we can host the AutoCAD plan so that the floor plans comply. Fine. For that, I'll just go to this particular insert and import CAD, and with that ground floor layout and inch and manual center, and I'll just open, and I'll just put this particular floor plan over here and VG, and I'll just turn this ground floor layout in this particular floor plan to halftone. Fine. And with that, I'll just modify, align, and click this dot and click this point. Again, click this dot and click this point. Fine. So the AutoCAD plan is perfectly in place. If you go to footing top, then also you will be able to visualize that particular AutoCAD plan. I'll just turn this to, let me see that it complies. Yes, it does matches. Fine. So I'll just change this particular view range and change this top and the cut plane to just 2 feet. So we'll have able to see only the designated those 3D elements on that particular floor plan. Fine. Now this particular ground level, we need to create a lot of elements over here. First is that we will start by placing the ground beams. Okay, so the structural consideration says that this is the ground road level and 2 feet of plinth we have. So we will have the inverted beams. So the ground beams and the plinth beam will be one and the same. Okay, so that is the structural consideration. I'll just go to this particular ground level, and herein I'll just go to this structure and beam. Fine. And for this particular beam, I have this 9 cross 12. This is the concrete rectangular beam that I have loaded. Fine. I'll just go to edit type, and I'll just duplicate this, calling it 9 cross 2 feet. Okay, and here in the height, I'll just change it to 2 feet and apply and okay. Fine. With this, now I will start placing those beams onto placement plane, ground floor level. Okay, and the Y justification and Z justification to top. Fine. So let's just start placing. Let's press place 1 and we cannot see it. And beam, and why is that we cannot see it? Well, because the Z justification is top. So the top of that particular element will be laid on this particular designated floor plan. We'll say that I want to see the bottom of that element. So with that, I'll just place it and beam, and I guess that Y justification should be left or right. Fine, and I'll just place 1. Okay, so that way the beam has been created. Let's see it in 3D. Okay, that's perfect. Okay, so these are the concrete rectangular beams, 9-inch across 2 feet. Okay, that is the ground beam and plinth beam. Fine, so now we need to quickly create the different beams on this particular floor plan. So ground level, and what I will do is that I will just hide this particular AutoCAD plan for now so that we can visualize. No, but if I just hide the AutoCAD plan, then we'll not be able to visualize the. So select this and say that CS, and with that pick lines, I'll just pick 1 with that Y justification to left is snapping this ways, 1 and 2 and 3, and herein I'll just say that this Y justification to be right. Okay, and just trim this particular thing, and here too I will just say that the Y justification to right. Okay, and just trim TR. Okay, and CS, and create this. Okay, this all the way till this point, and here we have continuous beam, but right now let me just first complete this. I'll just place it here and TR and join this to this. Fine, and CS, and here also we will have 1. Again, this Y justification to left, CS, and this too. Actually, this we can directly connect over here, and likewise I guess that we don't need this, and I just TR and join this to this. Okay, so that's perfect, and likewise this should be snapped here to the center, and with this where we have laid all the ground and plinth beam. Fine, let me just turn this particular imported categories, and let me turn this drawings to halftones. You can properly visualize the structure. Okay, so now next is that we need to create the different components and different elements at this particular designated ground floor level. Fine, so first will be the compound wall. So we'll just go to this particular ground floor, and herein let me just hide this particular grid lines, hide category, and hide while this hide category. Yeah, fine. Okay, so first is that WA wall, and I will already define that particular type, main wall 9-inch compound wall, and I will just go to edit type and edit structure. Then you see that it had this 9-inch thickness and a material of stone wall had been applied to it. Fine, so how to create material in Revit? So let me just show you that how to create material in Revit. One way is that you can select this particular existing materials of Revit, make them a part of asset browser, fine, material browser, sorry, and just duplicate it. Or another way is that just click this particular default, and with that default just right click and duplicate material and asset and just name it whatever you want. Fine, and from here you have this asset browser. So from this asset browser you have this appearance library. Under that, all predefined materials of Revit has been made. What you just need to do is that select any of the material and just replace this asset, replace the current asset in the editor with this asset, and just replace it. So that particular material will be snapped to that where is that default the one that I created, custom material. Yes, here it is. So see, that material has been snapped to this particular, the one custom that we created. Just what you need to do is that just duplicate it, since you're going to make changes to the tiling of this material, and don't mess up. I don't want you to mess up with the existing materials of the Autodesk Revit. So fine, just duplicate it, but I'll just delete it, or let me just press cancel. So that is how this particular stone wall material has been applied. You can also give it a plaster layer down, and you can select the same material, copy and paste, and call this half inch and this to half inch. Okay, fine. So just click OK, apply, and OK. Fine. With that, just say that finish face exterior, or sorry, core face exterior, since we have applied the two layers of plaster onto else, which you have applied the same material. So herein, I'll just click this particular rectangle and draw it from this point to this point with unconnected height, not up to print level, but I'll say that unconnected height and unconnected height of 8 feet. And with that settings, what I'll do is that you see that automatically that layer of extra layer half inch has been added to finished layer. Fine. So I will just place it from here to here. Okay. And if I just turn this detail level to fine or medium, and you can see that 0.5 of an inch, the layer has been placed. Okay. Now what we need to do, we need to go to structure, and again I will say that this particular footing, strip footing, which the footing that is hosted by a wall, and from there I'll just click this particular 2 feet cross 2 feet. Fine, because as per the AutoCAD plan, if I just click WF, where can I see that? Yeah, so modify, and if I just measure this, then give us 2 feet. Yeah, fine. So I'll just go to the particular ground level and structure and wall, and 2 feet cross 2 feet, wherein the width is 2 feet, its thickness is 2 feet. Fine. And concrete cast in place gray. Fine. And I'm just going to select 1, 2, 3, and 4. 4 of them. Fine. I'll just go to footing top, or let's take a section from here. Section, and drop this section. And yes, so see that particular footing has been laid on the bottom of that particular wall at ground floor level. Fine, but it is most likely to possible that here we have adjoining plot of someone else. So with this, you need to shift this particular footing in place and flush. You need to flush this face. So modify and just measure this, and this is how much? 7. Fine. So what we need to do, just go to 3D, select this one SA, that will select all of them, and say that the eccentricity should be -7 inch. Fine. So that with that, now we have a flush surface. Fine. Okay. So that is how you create the strip footing for compound wall. Okay. Let's again go to ground level, and from here, I guess that if this is the entrance, then I need to edit profile, and somewhere over here, HL, that is hidden line, I need to draw one line. Okay, and have a closed shape. Okay, and just get rid of this, and this we will adjust it later, but right now let me just see whether, yeah, that's perfect. Okay, but with that, this has lost its connection. So again, ground floor level, but you cannot see that particular thing in ground floor level. This should be snapped till this particular point. Okay, yeah, fine. Okay, so the strip footing continues, but the wall had been deducted in order to have an axis, and this one, this should flush with this particular thing. So I'll just say that TR won't work. I'll just go to ground level, and herein I'll just say that RP and move it half inches. Okay, and just drop this particular wall till this, extend it a bit so we can have a snap point. Yeah, fine. Let's delete it and go to 3D. Yeah, fine. So we have perfect flush face. Okay, R enter. Yeah, fine. So now we need to create the different floor plates of this particular designated ground floor level, and I'll just go to this particular ground floor, and I have already created that. So we'll just quickly lay that. So floor and floor architectural, and first is this parking strip. So where is it? Parking, and I couldn't find it. Parking quota, yeah. If I just go to edit type and you see that it's given the default thickness of 2 inch and this entrance quota, this material has been assigned to it. Okay, there's the custom material which has been created the same way I just showed you that how to create a custom material and assign the JPEG image to it. Okay, and I'll just click OK, apply and OK, fine, and just create a boundary from here to this point. Okay, and just but this will be laid in the bottom, fine. So what we need to do, we need to give it a height offset of 2 inch. Fine. Yes. Okay. Now let's go to ground level again and create this particular pathway. So all of them has been created. Floor architecture, and next to parking quota is this particular pathway edit type. And again, all the default thicknesses has been given. Actually, first when grounded, while coming to this particular ground level, there will be a layer of PCC along the entire site in order to ground the level. The hard payments, the areas which will have the hard payments or the hard surfaces will be given a layer of PCC, and then the material will be applied to it. You can also do it for the same. You can just go to edit type and herein what you can do is that just insert and just to be finished 1/4, and that could actually control C and control V the finished floor level, which will be 1 inch, and just roughly consider this as the PCC layer, and I'll just say that one sand bedding or PCC. Fine. So this is how you can edit a material, apply and OK. And with that, I'll just drop this particular entire pathway from this point to this point, and from here to this point. Okay, and I'll just delete this unnecessary lines and just split 1, 2, TR and drop this. Oh, sorry. Split this surfaces, this lines also, and then TR, join this to this, and join this to this. Okay, and that is how we have a closed shape, and fine. Just finish. Okay, so R enter, and that material has been created. What you need to do is that now adjust this particular compound wall and bring it in place. Fine. So likewise, I'm just going to create the different floor plates of this particular ground floor, wherein you can just edit it and give the required dimension as per your need. But right now I'm just not going to take into consideration the PCC. I'm just going to lay the different floor plates. Fine. So architecture and floor architecture, and next will be this garden. Where is it? Yes, here, grass. And just edit, and that has been given the material of grass, and that is the pre-existing material of Autodesk Revit. So I will just create different floor plates pertaining to that, and we'll need to have a little bit of drafting to be done. Yes, delete it and delete this line as well. HL hidden line is better visual for creating this thing. And okay, and again this should be pick lines 1, 2, TR, join this to this and this to this. Okay, and again say that rectangle, and from here till this point, here till this point, here till this point, and rectangle, and create couple of rectangles, and once that's done, we will have a different, we'll join and make it a closed loop. TR and join this to this, TR and join this to this. Fine. So with that, now I guess that this line should be here, and this should join with this. Okay, so with that, I'll just finish. Lines must be in closed loop. Somewhere we might have where is it? Finish. Yeah, see, delete and TR and join this to this and just finish. Okay, R enter, and yeah, fine. So what next now? That we need to this, I guess, that edit boundary, and line from here to here. Let's snap quick lines 1 to 2. TR, join this to this and join this to this. Fine. Now is that backyard and this particular thing. So that has also been created. Floor and floor architecture, and where is that backyard? Have I created one? Backyard. No. Earth. Earth will be the material that will be following other areas. Let me see that where I have made that material, and I couldn't find that. And I guess that, yeah, here it is ground floor, ground road level PCC. Yeah, see, so this is that material gravel. Fine. So what you need to do is that just create a close shape by drafting the different areas. And once that's done, just have a close shape once unjoin elements. Yeah, fine. And also this entire chunk. So just draft from here to here. And from this point to delete and have a close shape. Get rid of this extras and just draft quick lines 1, 2, 3, 4, 5. This is not needed, so just join this 2 lines TR and join this to this, this to this. LI and yes, and just finish somewhere. Yes, so TR and join this to this, continue, TR, join this to this and finish. Or continue and delete. You cannot have multiple lines, overlapping lines you cannot have, and you just need to have a close shape followed by one single line. Highlighted lines. Just finish. So delete. Yeah, everything is perfect. The way it was creating a problem. TR and join this to this, join this to this and finish. Lines cannot intersect. Yeah, so here we have a problem. Fine. So that's all, and yeah, fine. R enter. Okay. So now what remaining is this particular wash area. So that also has been created. FL architecture and floor architecture and washroom tiles. Yes, upper ground wash tiles. This is the material node, so that according to something else. I guess that here, let me just check in this particular project. Well, I don't remember, a lot of floor plates I have created, so I need to check. Yeah, it is that same washroom tiles. Yeah, fine. Okay. So let me just go to ground level, and here two areas will have that. This is the swimming pool and this is the wash area. So washroom tiles, HL, and just have a close shape here and here. Okay, and yeah, finish. R enter. Let's complete this particular swimming pool. So I'll just say that WA, and I already have that wall defined, pool wall, and if I just go to edit type, that have been just given a retaining material of retaining wall, and this is the material retaining wall. Fine, and it is 9 inch thick. That will just be a for the So I'll just go to this particular rectangle, and with that finished face exterior, I'll say that ground ground road level and unconnected height of, let's say, 2 feet, because 2 feet is the plinth. Fine. So I'll just create this particular wall. Okay, and yes. Okay, onto the on that particular thing, we will just lay the material of water. So architecture and floor architecture, and herein just say that water. Okay, and 2 inch that have been applied the material of water, existing material of Revit, and I'll just select this particular thing and HL from this point to this point. Okay, and at ground level, but I'll give the height offset of, let's say, 18, let's say 20 inches, and just finish. Let's see it in ground level. Yeah, fine. Okay, so that is how we have made this particular thing. But now we need to make the plinth. Okay, and before that, let me just create this particular road and earth. So floor, architecture, and road, and I'll just create this one. And I'll just get rid of this TR and join this to this. And finish. And now let me just hide this elevation marker, hide in view by category. Yeah, that's fine. And again, go to floor, architecture, and earth. I already defined that. Yes, and that have been just given material of earth, existing material of Revit, and rectangle. Just select this entire chunk and pick lines. And I'm just going to exclude so much of the portion. Pick lines 1, 2, 3, 4, 5. Okay, TR, join this to this, and join this to this. Fine, and we have a close shape and finish. R enter. Yes. Okay, so now we need to create the plinth, and that I'll do it quickly. So what is the consideration there here? If I just take this particular section, and if we have a plinth of 2 feet, if we have a plinth of the particular 2 feet essentially, then we will run the coping for this particular plinth. We will run this particular coping along the periphery. Fine, and that would be only size of that particular layer of PCC which will be laid on this particular. There will be no floor slab casted on this particular level. There will be a layer of 2-inch PCC, 6-inch PCC. Fine, so we'll have a coping, a beam that will run along this entire periphery of 6-inch, and rest we'll have the wall. So I'll just go to this particular WA wall, and I'll just click this particular main wall 9-inch, and just go to edit type and edit. And you see that it is the wall plane and plaster 1/2 inch here and 1/2 inch here. Fine. So I'll just go to apply, and from ground level, I'll just give it an unconnected height of 18 inches and just draw it. Sorry, just draw it from this point. No, this should be core face exterior. And just draw it from this point along the periphery. Yes. Okay, and this are the retaining walls. So RCC wall, RCC pardi. So okay, and now on the top of that, we are going to lay the floor plate. Okay, but before that, I need to create this particular beam coping of 6-inch. Fine, so duplicate and just call it coping, and the breadth should be 9-inch, but the height should only be 6 inches. Apply and okay. And oh, sorry, that was not supposed to be changed. Just undo it and just select this particular thing and go to structure and beam, and then edit type and then duplicate it. But yeah, we have already created, it's fine. You can select just that and okay. And from this point, the bottom should be laid, the top should be laid. So from this point to this point, I guess the bottom should be laid. HL, and from this point to here, or we placed it 2 times, so we need to get rid of one of them. One, two, and three, and from here we'll start placing it again. Okay, fine. So let's go to 3D, and that have been laid at I guess that wrong place. So just hide this particular wall, hide category, and yes, SA. So let's just change this particular to bottom. So that will be place, and just select all of this SA and give it a Z offset value of 18 inches. Okay, perfect. Fine. And HR. Yes, onto this. Now we can lay the floor. Okay. And that particular floor has already been designed, but what we just need to do is that select all of this and say that the unconnected height should be 2 feet. Fine. I made it 1 feet 6 inches because I wanted to show you that how could we lay this particular coping. But now we need to go to modify and join all the structural elements with the architectural elements. Fine. 1 to 2. Yes. Okay, let's get rid of this extra plaster layers. At all the junctions. If we cannot model with this precision, then there is no use of using Revit. This will be exactly quantify the materials. Okay, and oh, sorry. Yes, this is done. And this, I guess, okay. Here there's a problem, I guess. Yes, and the problem is that we need to shift this particular, we have not placed this particular thing. Perfect. We need to move it and move it 0.5 inches. I guess this wall has not been placed properly. Move it, okay, snap it here. Let's move it from this point to this point. And from there, now just move it 0.5 inch. Okay, perfect. No issues. 3D. Yeah, and you just need to join it. Yes, okay. So now we can quickly create the floor plate of that particular plinth. But on the ground floor, there will be floor plate or PCC, that is the plain cement concrete, and there will not be any RCC since that floor plate will be resting on the ground. So we generally don't provide reinforced cement concrete, but we generally provide PCC of 6 inch. Fine. So I'll just show you, even this particular wall will not have the plaster in the interior face because that is going to be the filling. Okay, so I'll just show you once we lay that particular PCC layer on that particular ground road level. But that will be at the height of, let's say that at this particular portion, it will be there. Okay, let me just turn this to fine, and let me just scale it down a bit. You can properly visualize. And here there will be a 6 inch PCC layer. Fine. So I just need to go to ground floor, and herein I just changed to shaded so you can properly visualize. CC, no, shaded is proper. So I'll just say that architecture and floor architecture. And let me look for RCC, plinth level RCC. I've already created, I guess. Plinth and ground floor. Yeah, ground floor PCC, not RCC. Sorry. Ground floor PCC. And if I just go to edit type of that, and that is just a 6-inch layer of sand bedding PCC. Fine, not RCC, but just the plain cement concrete. And with the height offset of 1 feet 8 inches, that is perfect because 1 feet 8 inches, or no, from ground level, it should be at the level of, it should be height of 1 feet 6 inches. Fine. So I'll just drop this particular boundary line, and from here, I'll start creating that layer of PCC along different areas. Okay. And this will have, but this is the sunken courtyard. So this much portion won't have that. And this is entirely okay. And likewise, I need to create that layer here as well. Okay. Excluding the plaster layer of the wall, inside plaster layer, which will actually not come. I just drafted to show you guys, make you explain. I will just change it once we are done with this particular. And yes, and from here, again, this much. Okay, and now we need to have a close shape. So let's just get rid of unnecessary lines. TR and join this to this. Join this to this. Join this to this. Here we have a couple of lines. So just delete this line and TR. Oh, sorry. TR and join this to this and this to this. Okay. So we will get rid of this line and TR and join this to this. Also, we'll get rid of this entire chunk. We need that line, so we'll keep it. And join this to this. I hope that, oh, sorry. This we will get rid of. And herein I'll snap to this line. Okay, and this should be okay, fine. So that is how we have created the closed shape, and I hope that, fingers crossed. Yes, perfect. We just go to 3D, then you see that the floor plate has been laid, but 1 feet, let's see it in section, ground level, and yes, okay. And what is the issue? Okay, height should be 2 feet, I guess. Yes, fine. And okay, absolutely perfect. So this is the ground beam and plain beam, and this is the floor plate of PCC, the layer of PCC. And here, only along this particular entire peripheral edge, at this point, you'll have the reinforcement. Okay, fine. So now what needs to be inferred is that this wall should be in a such a way that the plaster is only on the exterior side, because inside here there will be a filling. Here there will be filling, so no need of creating a plaster. So such wall. So what I'll do, I'll just select that particular wall and press SA. That is, there will say select all the walls of that particular category, and from here drop it down and just select that particular ground beam external wall 9-inch plaster. And if I just go to edit type and edit, then you have for this particular thing, this is the wall paint, that is the material of the wall. Fine. The masonry part, the 230 mm, 2 brick thick, 230 mm wall, 9-inch wall. Okay, which actually don't need to be given this particular material, only this material on the exterior side of this particular plaster. Fine. So I just say that apply and OK, and all of that will be ground beam external wall 9-inch plaster. Fine. With that, now if I just go to this particular section 1, then you see that you don't have plaster on the interior face. Here we have masonry, here we have plaster, and here we don't have that particular plaster. Fine. The same thing is also true for this particular beams. Okay. This particular beams need to be snapped with that particular same wall. So I'll select this ground beam external wall 9 inch with plaster on one side and this RCC beam, and I'll say that isolate category. Fine. With that, we'll just have these two layers on, so we can snap this particular walls to rest of the external beams wherever needed. I'll select this particular wall CS, that is create similar, and I'll just say the pick lines, and with core face exceeded with the location line, I'll just select this. No, this, yes. So let's see that where the layer of plaster has been added. It has been added on the wrong side. So just click undo again, and let's say that let's go to top, and with that CS, let me just place it wherever necessary. Yes, and 1, 2, and this, and here, here. Let's place them all, place it till this point. Perfect. And just go to, yeah, we are already in 3D, just watch it. Okay, so with this, now what we need to do, I will again say that HR, select this wall, HH, and we have this particular beam, this beam wall, this RCC beam. At the same time, we have this columns. Fine, so all of that we need to say isolate category. Okay, and we just need to join. The beam didn't get selected, so let me just select this RCC beam column, this wall, and the beam, and say that isolate category. Okay, SA and HH, the compound wall, and join, and real quick start joining all the walls with that beam. Fine, so you see that only the layer of plaster is getting added to the external surface, and internals we have the RCC, right? So this was the precision that I was talking about, which this will help a lot in scheduling. Okay, and do that real quick. Okay, this columns also needs to get rid of the plaster. Okay, and where else? Yes, perfect. Fine, and here, see, here still that we have an error. You just need to zoom in a bit and just check. Yeah, fine. I hope that here we don't have any issues. Fine. With that, we have perfectly CC R enter wrapped the layer of plaster to the exposed surface of the ground beam. Fine, HR. And now we need to create the rest over this particular steps which are leading to plinth. And here, no, but before that, yeah, first let's create the steps. No, but instead creating the step first, let's create the finished flooring of the different areas, okay, of this particular floor plate. Fine, so let me just go to ground level, and from here I'll just say that architecture and floor architecture, and plinth floor, washroom floor plate, and I'll just go to edit type, edit, and it has been given two layers, mortar 12 mm, see 12 mm L type, and this is the plinth finished flooring toilet. Okay, so this floor plate pertains to plinth floor washroom floor plate. Okay, of which on the PCC, on the layer of PCC, there will be a mortar and then the finished flooring. Apply and OK, and let me just create from the unfinished. Okay, let's create it from finished surface so we can exclude it later while going to the section. Okay, and where else it is? Here, I guess. Yeah, see, so this external face, okay, and this face as well. Okay, so this are two going to be the two and here also there is one. Fine. So with this, I'll just say that finish. Okay, and go to 3D. And we cannot see it, we cannot visualize it because that has gone down. So what we just need to do is select that and say that of offset of 0. Fine. So with that, the floor overlaps. That should actually be placed at plinth level and with offset of 0. Then two, it overlaps with the RCC, I mean the PCC slab. Okay. So what we need to do, we need to go to section 1. Where is the section 1? Yes, here it is. So let's take that take this particular section here and just watch the thickness of that particular finish flooring for the toilet portion or the washroom, and just check this UN and length, just change it to millimeters. Okay, rounding up to 0 decimal places, modify and just measure it. 19 mm or 12 mm mortar and 19 mm finish tile, so it is 24. Okay, 24 mm. So just again come back to this and just change this to feet and fractional inches, rounding up to 1/4 of an inch. Okay and okay, and just select this particular thing, and on from plinth level just change it to 24 mm of offset. Fine. Okay, HR, perfect, no issues. Okay, here I guess that I need to get rid of this particular, because we cannot have that and loop, because this particular level is different. And here too, I guess that on ground floor level, CC, there will be a floor plate of PCC. So just go to architecture and floor architecture and ground floor PCC, plinth level PCC. Mm, Plinth level PCC, where is it? Yeah, ground floor PCC, sorry, plinth level. Ground floor PCC, fine. And just click this particular rectangle and just create one. Okay, and just finish with offset of 0. That will be laid at perfect place. And now just go to floor architecture, and herein again select that same first floor, no sorry, ground floor, now plinth level washroom plate, and that same plate will be laid here. Okay, but herein we will lay it at ground floor with offset of 0, HL, and just click this rectangle and just create this and just finish. So highlighted floors overlap, yes, just give it a offset of 24 mm. Fine, and 3D. Okay, so that has been perfectly laid. Also, just get rid of this hide in view by category, this is distracting the 3D part. Okay, and this, I guess that edit boundary and go to road level and pick lines 1, 2, 3, PR and PR, and split this and join this set and finish. Yes, okay. Now come to ground floor again, fine, and create the several different finished floor layers, the floor plate, finished flooring for that particular plinth floor. And we'll start with this bedroom. So I'll just go to this particular floor architecture and plinth floor public areas. Yes. So if I just go to this, then this is the mortar and the finished floor public 19. So 31 mm finished flooring. Okay. And this material has been applied to it. Okay. So I'll just quickly draft that with respect to this outer line. Okay. And I should have taken this all the way till this point. Yes. And pick lines and just pick BM, that is mirror, or BM. Okay, and just split 1 to 2, 1 to 2, Okay, and yes, snap 1, 2, 3, 4, and just have a close shape. So this pertains to the public areas on that particular designated level. Okay, and delete this finish. Okay, and also yes, also this particular thing we need to take into consideration, and we need to discard this particular courtyard area. And line and this 1, 2, 3, and 4, 5, and just PR and join this to this and this to this. Okay. So this entirely pertains to the public areas on the ground floor and not this bedroom. Yes. So this needs to be joined here. Okay, let's take this line over here. Delete PR and join this to this. Okay, and this to this to this and finish. Okay, the highlighted floor overlaps because it is the I forgot to change the constraint and it should be at plinth level. So still the highlighted floor overlaps because it is casted on the RCC, this PCC. We need to take it above and how. So let me just measure this. So this is the finished flooring. If I just go to this particular, it's 31 mm, fine. So what we need to do, this, yeah, 31 mm. So just give it a height offset of 31 mm. Okay. And now if I just go to this particular ground floor and if I take a section, this section, then between the washroom tiles, the washroom finish flooring and this finish flooring, we would have definitely one tile drop. Let me just turn on this to fine and put in ground level and yes. So why is it not? Uh, oh, okay, fine. Because this here it is still empty. Fine, doesn't matter. I'll go to architecture and floor architecture and plinth level private areas. Fine, that has been assigned a different material and still have a thickness of 31 mm. Fine, 12 mm mortar and 19 mm finished tiles. So with that, I will just draft this particular entire private areas and also this. So I'll just snap 1, 2, snap PR, join this to this, join this to this. Okay, and just finish. Oh, we need to finish and just change this particular level that I wanted on plinth level and with the offset of 31 mm. Fine, and just finish. So now if you just watch this section, then what do you notice is that we have one tile difference between the finished flooring, washroom floor plate, finished flooring of washroom toilet, which is 24 mm. Yeah, fine. 24 mm inclusive of 12 mm PCC, the mortar, and 12 mm finished tiling. And we have a one tile drop. The water won't penetrate on the finished flooring areas of this particular private areas. Okay, so that is how you model things in Revit. Fine, now what left is to create this particular thing, entire the finished flooring for this area. And before that, let me just go to this H8 and just select this and edit boundary. And let me just draw that particular ground level PCC here as well, courtyard area. Okay, R enter and fine, we have that. Okay, so now we need to draft the finished flooring for this. So again, I'll go to floor architecture and where is public areas we use entrance deck. Yes, and plinth flooring, plinth finished flooring. And yeah, this is that particular same. So that will be mortar, and on the top of that we will have the finished flooring. On this particular PCC, we'll have the mortar as the finishing material, binding material, and then the finished flooring. So HL, and you need to again draft this profile. So just draft it all the way till this point, and take it here. Okay. Line 1, 2, 3, and line 1, 2, join this to this. And just stay tuned. Complete it real fast. Yeah, and join this to this, join this to this, join this to this. And also we need to draw this profile. Yeah, and join this to this. I hope that we don't have any lines open. We need to trim this, have a close shape. And here there is a little problem, but that we'll figure out once we complete this. Okay. Sorry. This should also be at plinth level with the offset of 31 mm. That's fine. You just go to road level. Okay. Advice. Perfect. Okay. So this is the PCC floor plate, which is supported with this coping at the end. Okay. And this is the masonry work, on which the plaster is embedded only on the external side, and on the top we have the finished flooring. Okay. But what is the problem here? That this particular wall, I guess that I need to flush it. And you see that we have a problem here, and I might have snapped to some wrong lines while drafting, and so this is going to be really tiresome and time consuming. Yeah, see, so this is, if this is the AutoCAD line, if this is the AutoCAD line, yeah, fine. So I was supposed to snap it here. So doesn't matter. Let me just go to 3D. Page R. Yeah, fine. So here there is a problem, right? So what we need to do? First, let me just hide this deck. And R enter. What is this? Ground floor PCC. Let me hide that also. And first is that let's move this particular beam, the scoping, in place, which is right now not. And let me just get rid of this wall as well. Delete HL and wireframe. And this should actually snap to this point. Okay. And with that, now if I again select this scoping, no, this is again a wall. So again go to 3D, hide this, drawing geometry, and get rid of this extras. Okay. Undo. Yeah, fine. And, let me just join this here. And I hope that we have a flush surface. Yes, but we need to also deduct. Okay, so ground floor, and now just HR and this PCC, ground floor PCC, we need to edit boundary and drag it this a bit. Okay, with this we have a clean joint. Okay, and HR. Yes, so what we just need to do is that we need to draw here the beam wall. So press tab until you find that coping, not coping, but the beam wall. Why I'm not able to select? Press tab a couple of times until you find that, yes, ground beam wall, and just draw it from here to here, this point. And finally, so see, sometimes small things create a lot of problem. Okay. And with that, just modify and join this to this. Okay, and join this to this. Okay, perfect. No issues, and we have a flush surface over here. Fine. I guess not. Yeah, fine. It's okay. Let's not waste more time on this. Okay. So with that, now we have created all the finished flooring, finished floor layers for that particular plinth level. So let's create this particular couple of staircase, WF, and here there are some, here there are some, and here I guess we will have an access. Okay. And also this courtyard. Fine. Here also we will have. So ground floor PCC, and we did that boundary as well. Suppose that this was supposed to be created from this end, not this end. Delete and just R enter. Okay. No, still, yeah, the solid floor layer also needs to be HL, sorry, wireframe, and just snap and just finish. Okay, R enter. That's perfect. So we need to create this particular interesting three to four staircase. Okay. So let me just delete this particular thing. Okay. Let me just go to architecture and stair type. Stair type we didn't uh, supposed to pass on that also. So it doesn't matter. Let me just go to this manage and transfer project standards. Copy from this and check none. And stair type, do we have option to copy the stair types? Yes. Fine. Okay. Yes. Override. Was it a monolithic staircase? HR. Let's just check. So cast in place. Yeah. Yeah. So the monolithic staircase. Okay. And there have been applied the material. Okay. Copy. Just copy it because that material would exist in that file also. Now this has an interesting profile. Fine. So I'll just go to architecture and stair. And with that particular ground to plinth, monolithic steps. Fine. This UN, I need to change it to feet and fractional inches, and this is the best part of Revit. Then you can switch between working units and run. And with two desired height 2 feet and top level plinth level, and everything desired number of risers 4. And the material has also been copied. That's fine. And what I will do is that HL, and I'll just run. But this actual tread depth. What is the tread depth here? 1 foot 6 inches, and then it is 1 foot 3 inches, and then it is 11 and a half. Okay, so interesting. So let me just click for now 15 inches and run actual tread depth, and I will just create this particular staircase. Okay, with this now I have the ability to convert it to sketch. Oh, sorry. Convert it to sketch base, which says that it is irreversible. That's fine. And edit sketch. And now I'm just going to drop this boundary line. I'm just going to delete this boundary line and just snap that here. Okay, and snap this to this line and this to this line. Okay, and risers, and I will just pick lines 1, 2, 3, 1, 2, and WF, and this 3. Yeah, fine. Okay, so this should be a plaster layer should be avoided. And just join this to this. Join this to this. Okay, and I guess that the boundary lines will come here. Okay, so Just join this to this, and then boundary line, and just draw two boundary lines from here to here. One over here, one over here. Okay, fine. So this is Revit, this is not Google SketchUp. So you have an ability to create stairs like this within that stair assembly and just finish. And just go to 3D. That has been drawn in wrong direction. So what you need to do, you need to just say that like okay, and that particular staircase has been created. Beautiful. You just need to get rid of this particular railing. Okay, so just like that, I'll just go to ground floor real quick and say that CS. And with that, now this is the uniform tread depth, 1 foot. So I'll just enter here 1 foot, and then that's fine, run and run from here to here. And there is no need of converting to sketch base. We should have entered this tread depth 6 foot in run, and since it's an instance parameter, so 6 foot and 1 feet of tread depth, and from center I will just create this. Okay, 1 to 4 and just finish. Okay, just get rid of this railing. Likewise, this is again going to be an interesting stair. Okay, and just move this bit here. Okay, page fell. Okay, so this is again going to be an interesting staircase, wherein I'm just going to say that CS, and what we need to do, we need to say that run, and with that 1 feet tread depth, that's fine. Is it 1 feet? No, it is just 6 inches. So they said say that 6 inches and run, and width will run with 6 feet. That's fine, because anyways we are going to convert it into sketch and we are going to edit the sketch. Fine. And select just and edit the sketch, wherein I'm just going to say that this particular boundary line should be like this. Okay, and trim extend multiple elements 1 2 3 4. Yeah, fine. And just like that, snap this here and snap this here. Trim extend multiple elements 1 2 3, and with that just finish. Oh, and go to 3D. Yes, perfect. Okay, just delete this railing and go to ground floor. DM, that is mirror it from here to here, and likewise just copy it and rotate it in order to snap to this face. Edit stairs, edit sketch, just move this to here and move this, so not the stair path, the boundary line. Okay, and TR, 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 and TR. Okay, and just finish it. Finish. And this should DM, that is mirror, and okay. And now let's just see it in 3D. And absolutely perfect. Okay, all the staircases have been made. Oh, this was remaining, the one which will drop from kitchen into this particular wash, but that will be very easy. And this how to, let's say that the staircase I'll just copy just to save time, and I'll just rotate, and just flush it 3D. Yeah, that's fine. Don't want to waste time on this. Okay, so with that, we are completely done. With so much of hard work, we are completely done with up to plinth level. Okay, but that hard work is worth it, because with this you'll be perfectly able to schedule it and quantify it, and properly the costing will be done. Okay, the only thing is that this finish levels, see, all this finished levels should be given offset of, let me just go to ground level, and this ground level PCC 2 inch, yes, garden 2 inch. Okay,
Yes, 2 inch, garden 2 inch. Is anything left? Pathway, and that I guess that okay, that's also be given 2 inch. And this parking, 8 feet, and parking, yeah, that's 2 inch. Okay, fine. So with that, now if I just go to 3D, then we have this perfect. And if I just go to ground floor and extend this section a bit, go to this particular section, then let me just hide in category, hide in category. Okay, what you see that this particular finished levels is resting on this strip footing of the compound wall. Fine, and that is the perfection which I wanted. So modify and just join this to this. Okay, so you have to do it on both the ends and for both the sections, longitudinal and vertical, both the sections. But right now I'm just showing you to not wasting time. I'm just showing you the concept. Yeah, fine. Okay, you can do it for the horizontal ones. Vertical ones I showed you. Now, what is next? Now we need to start elevating this floor plates and this structure. I mean, we need to start elevating this walls above this particular floor plate, this plinth level floor plate. Okay, so let's just go to plinth level, and now we'll draft in plinth level. And we don't have the AutoCAD plan, I guess. Let me just hide this unnecessary thing. Hide it by category. Just delete this particular section and HL R enter. Yeah, but we need to snap AutoCAD plan onto this particular level. So how do we do that? Again, going to ground floor level and WF and this particular line, edit work plane, and should go to plinth level and OK. Fine, but it should be visible here also, since the plinth level is only 2 feet and the view range of this particular ground floor level will be 760. Yeah, so let's change it to 2 feet so we can just visualize what all is needed on this floor plate. Okay, what all is getting cut at this level, 2 feet level from ground floor. Okay, and I'll just go to this particular plinth level and 8 feet, and there is the AutoCAD plan HR. Again, we need to R enter. Where is the AutoCAD plan? Plinth level, ground floor WF, and 8 feet. This is road, and yeah, the import symbol ground floor layout is still at ground level, so we need to send it to plinth level. Fine. With that, WF, and now we have the AutoCAD plan here on plinth level. Okay, so we can start elevating the structure above this level. So let's just turn it to wireframe until we can see that particular AutoCAD plan. Okay, and let me just go to VG, imported categories, and turn this ground floor layout to half tone. Okay, and one thing I guess that I forgot, that was creating this particular R enter, and yes, so the finish level of this particular is remaining. So real quick, I'll just select this particular thing and see, yes, that is create similar, and just a rectangle and HL, and from here I'll just snap it. Okay, and just finish, but I'll just take it to ground floor level. Okay, with the height offset of uh, 31 mm. Okay, and with that, if I just take a section, let me just take this particular section and view it. Okay, so that has been placed properly. Okay, no issues. Only thing is that for this vertical section, we need to Oh, but walls has not been placed, so that's fine. Okay, we will do that later. I was talking about joining the geometries, but wall has not been placed right now, so fine. But what important is that I'll just click undo and I'll just shift this section here. So that should be a one tile drop. Yes, see, perfect. So this is called perfection in modeling. One tile drop between the finished flooring of this area and the toilet area. Fine. So wireframe. And now it is very, very important. Okay. So first is that I'll just go to this particular 3D, and from here in, what I will do is that I'll just go to left elevation or any of the elevations and just select all the columns, or let's say that select one column and SA, that will select all the columns. And first is that we need to elevate the columns as per the hierarchy of construction. So footing top, from top level to plinth level, and from from footing top to the top level, not plinth level but first floor, and that will elevate all the columns. Okay. And if I just say that SA and HI, then right now you see that all the columns are perfectly coming from this designated footing top till this particular level. Fine, and we don't have any issues. Fine. So now we have to start elevating the walls and building the walls. So it's very important now. So HL, and what you see, but with HL will not be able to visualize the AutoCAD turn. So I need it to turn it to wireframe. But you need to be very careful, as I said, that we will follow the exact process the construction happens on site. Fine. Edit type, and this should be flushed here, and edit boundary, and this should be flushed. Okay. So in order to do that, as per the hierarchy, this particular column to this particular column, there will be a masonry wall. Okay. So what generally people and students do in Revit is that they draw the entire wall. But then when it comes to scheduling and quantification, what about how to deduct this much portion of masonry from that wall? Because when you quantify that wall, it will be quantified on the basis of area and not volume. So area is its length by its height. So it will consider this length, entirely this length. But we need to deduct this particular column out of that masonry. So there comes the point that we need to follow the perfect modeling skills and modeling tricks with Revit. Okay, so WA. And what I will do is that I just go to this particular main 9-inch wall with plasters on both the end, both the sides, interior, exterior. Okay, and with that, I will just say that core face exterior, but the base constraint should be plinth level, and the unconnected, very important, should be first level, but with the negative offset of 1 feet 6.5. Why is that? Because 18-inch, that is 1 feet 6 inches, will be the beam depth, and there will be a layer of plaster wrapped to that beam also. Fine. So this particular wall needs to have an unconnected height of 8 foot 7.5. So that will calculate the amount of masonry. Fine. So from here to here, and this are the internal walls. So from here to here, and from here to this point, from here to here, and likewise from here to here, here to here, and likewise press space and flip the direction, and this C. Okay, and fine. So far, if you watch my earlier tutorial, then I also was following the same process. But as I said, that learning is lifetime. So with every batch, I discovered something new. So that is what I have discovered in this batch, that this should be the perfect model. Last batch, Gen batch, that this should be the perfect modeling tricks with Revit in order to properly schedule and quantify it. Join and join this to this. The external layer of plaster is joined. CS, again draw from here to here. Again draw from here to this point. And yeah, this is drawn. No, drawn. So CS from here to here and from here to here. Okay. And now here we need to place the internal wall. So WA, and I have already created that particular 4.5 inch internal wall, wherein the layer of plaster has been flushed on exterior and interior side of that wall as well, which makes its thickness 5.5. Okay. So with the same constraints, I'm just going to draft that internal wall. Okay, and again, I'm just going to wall joints and say that disallow joint. This wall should stop here and this wall should stop here and join this to this. Okay, so likewise, this particular entire wall, so just drag it and CS from here to here, and this is the L shape. Likewise, stop it here and stop it here and continue it here. Wall joints, disallow join, yes and yes, join and join. Uh-oh. This is a bit time consuming, but it is worth it, because if you cannot draw with this precision, then there's no point using Revit. Okay, and I'll just say that CS, create similar, and I'll just draw those two walls here also, internal walls. Okay, fine. Now, what we need to do, we need to go to 3D and just see that how this wall has been created. Okay, and it's perfect. But what important is that now this layer, there should be a layer of plaster across this wall, which when quantified, the masonry, the quantity of masonry won't count that layer of plaster. So what should be done in that case? Here I guess that there is a problem. So I guess that here too, I guess that disallow join, and this should stop here, and this should stop here, and just join. Okay, fine, no issues. But now we need to wrap the layer of plaster, these columns. So how are we going to do that? So under this architecture tab, we have this column and column architecture. Fine. And under this, we have several different types designed, of which I'm just going to select any one type and duplicate it and call it 10 cross 19. Okay. 10 inch cross 19 inch. Why? Because there is going to be half-inch layer of plaster on both the sides. So depth would be 19, or yes, 19, and the width should be 10. Okay, 10 cross 1 feet 7 inches. Apply and okay. With that, just height up to first floor. Okay, and I will just lay this particular thing here and snap it. Oh, yes, snap it exactly in the center, but still again it is not. So let's go to modify and align. I guess that there is a problem with this particular wall. Yes, so you see that it has been snapped to wrong line, and move it inside. Fine, so perfect. Okay. And likewise, this too also needs to be snapped here. Okay, and now it is perfect. Okay, so with that, now I'm just going to select that concrete rectangular column, not concrete, but the one that we create, rectangular column, architectural column, and snap it across various columns. You just need to snap to the center line, and it will automatically get snapped. Okay, yes, this, okay, uh-oh, too fast, sorry. Like this ways, if I just go to 3D, then what you notice is that we have wrapped the layer of plaster to all the columns. Fine, only this one we skipped out. So CS, just press space and snip it. Oh, identical instances. Then where has been left which column? This is the same column. So where is it? Oh, here it is. Okay, so CS, not the concrete column, but the rectangular column, architectural, and just snip it. Fine. So with this, we have snapped. But still, you cannot see the uniform surface because this rectangular column has not been given the material, and I will just give it the same material of saying 1 plaster. And the material has not been defined. How is it possible? Yeah, 1 plaster. Okay, and apply and okay. Okay, so what we need to do now, we need to join all the elements. Fine, so just go to CC or enter, or which would be the proper view or to join. Yes, so I guess this is the proper view. To join and select, watch this point. It should read concrete rectangular column with this. Wow. Okay, let's scale this down a bit. Still more. Yes. Join and join this to this. Okay. Join this to this. Join to this and one more. Join this to this. But here we need to switch order. Yes. Sorry. Undo. Yes. And here we had a problem, right? So join and join this to this. But why is it creating a problem? This to this. And join switch order. This to this. No, but that is not. So what is the problem here? Undo. Sometimes Revit is really tricky and it's hard to. If I just delete this particular column, yeah, it is perfect. Yes, this particular wall. Oh, sorry, this particular wall doesn't need to unjoin elements. Not needs to continue here. Yeah, it should stop here. Maybe here, this point, and then again CS and continue from this point until you snap to this point. Okay, and just join this to this. Okay, and now if I say that join and okay, perfect. Yes, sometimes you need to be very precise and very patiently you have to do this, otherwise as you see that a lot of error pops up. So join and concrete column with the rectangular column. Fine, just like that. Concrete with the rectangular, we have already done this. Concrete with the rectangular, concrete with the rectangular, concrete with rectangular. And why am I saying that thing again and again? I guess that you guys are following. Okay, and yes. Concrete, watch this point. Rectangle. Concrete on rectangle is just a joint. And I hope this is also not concrete. Concrete with rectangle. Fine. So this ways we have joined all the columns. Okay. And if I just go to 3D, and you see that we have one homogeneous uniform surface. Okay. Only thing is that here, I guess that on ground level, it has lost its connection. Ground road level. Yes, not this here. Okay. But then this is creating a problem. What is the issue? Ground level. Let's join and join this to. Okay, this particular layer should stop here, I guess. Fine. So wall join and disallow join. Yes, and this should stop here, and this should stop here. Perfect. And then join it. Join the plaster layer to the plaster layer. Okay, and 3D. Yes, fine. Perfect. But this again seems not joined, which is that column. If this is the column, then that should be joined. Join this to this. Yes. Okay. Fine. What is the next step? Now we need to create the beams, that is the structural framing, across these columns. Fine. And for that, I'm just going to use a very quickly way and use the features and functions of Revit to do it easily. And what I'm going to do is that I'm going to select all this particular concrete rectangular beam, 9 feet cross 2 feet. Okay, that is the ground plane beam. And what I'm going to do is that I'm just going to say that those should be, first is that let it snap and paste align to selected levels and snap it to first floor. Okay, and just click yes. Okay, so that has been laid above the first floor. Okay, so what I will do again, I will use the tricks of Revit, where I'm just going to say that structure and beam, and this should be 9 cross 12 and edit type and duplicate and call this 18 inches, but that is already defined, I guess. No, it is not. So duplicate and call it 9 cross 18 inches, which will have depth of 18 inches, 1 feet 6 inches, 9 cross, apply and okay. Okay, and with that I will just select all these particular beams. Not been selected, just go to front elevation, and from here in I'll select all this particular beam and just change it to 9 cross 18. Fine. But what we need to do, we need to say that the Z justification should be the top of that should be laid at this particular plinth level. At this particular plinth level, the top of that should be laid. So top, and it is perfectly in place. See how beautiful. What you notice is that we need to get rid of. You see that this beam is intersecting this column, but this layer of plaster is not deducted. Fine. So what I'll do is that I'll just select this beam and select this column and this column as well, and just say that isolate category. Fine. With that, now I will just real quick say that join and just get rid of the plaster from that column, intersecting columns, wherever it is. So join and okay. Now, sorry, here too, one and okay. Just one click, it deducts the plaster. Perfect. See how perfectly you see that it is deducting the plaster from that much area. And this to this. Come on. Yes. Yes. And here we don't have a column because we are going to have a curtain wall onto that particular area as the opening. Okay. So now what we need to do? We need to wrap the layer of plaster just as we did for columns. We also need to hide this particular beam. Okay. In a such a way that it would only quantify the layer of plaster and it will extrude this much quantity of RCC beam. So how to do that? So I'll just go to the ceiling plan of this particular plinth level, ceiling plan of plinth level, yeah. And I'll just change this particular view range. I'll just change this particular view range to, let's say that the cut plane should be at 8 foot 6 inches. Okay. And with that, I'll just turn this detail to fine. And if we cannot visualize, just scale it down a bit. Okay. Still, the view range is the problem. So 9 feet. Yes, perfect. Okay. So with this, now you have to lay the layer of plaster onto those walls. So how will you do that? So I just click wall command again, WA. And here I have already designed that particular wall in order to schedule it differently. See, beam external plaster 9 inch. And if I just go to that wall, then the composition is the same, exactly the same, but it has been duplicated and given the different type and different name. So we can take out the quantity of plaster excluding this quantity of 9 inch, which is going to get joined with this particular concrete columns and beams. Okay. So with this, I'll just click OK, apply and OK. And what I will say that the constraint should be plinth level, but the base offset should be 8 foot 6 inches and the top constraint would be 0. Okay, so unconnected height 18 inches. Fine. So with that, now I will quickly draft from here to here. How perfect. See, we will need to stop here because there is a column there. And just like that, highlighted walls overlap. Yeah, that's fine. We will deduct it. Don't worry. So from here to this point, and this can be continuous because it is an L shape. And from this point to this point and up till this point, stop here and the L again stop at this point and draw this continuous L shape. Yes, one element is completely under another, that's fine. CS one, yes, and just draw till this point. Just perfectly have a look over the points I'm snapping to. Fine, just try to follow. And oh, too fast. Sorry. 1 to 2 and 3 and stop. Okay, just continue this particular thing all the way to here. And likewise from this to this, and from this to this. One last. Okay, for last ceiling plan and one last CS. And just join. Okay, but we need to join it, take it till this point. Fine. So with that, all the beams are wrapped with that particular wall. What we just need to do is that quickly join and select. Make sure that you select the framing, structural framing. Watch this point. Structural framing is to wall. Press tab. Structural framing is to wall. Okay, perfect. And here too, press tab until it reads structural framing with wall, and now I'll be pretty much fast. I guess that you understood the concept. Yes, yes, and this particular beam should, yes. Okay, Okay. Yes, perfect. And we don't have any issues there. And it is laying absolutely perfectly the way it is supposed to be laid with that hierarchy. Okay. Last one, I guess. And see, something always remains. So this part join and this thing should deduct this so oh yes. Okay, and this was remaining. Fine. And what is the case? I forgot to snap CC R enter, and I forgot to snap to this two faces, I guess. Or did we? Then why did it CS and join with the same constraint 1 to 2 and 1 to 2. Okay, and go to 3D, join, yes, yes, yes. Okay, so this is how perfectly you work in Revit. And again, this thing is always something I guess that I had drawn for this particular phase. Why is it excluding? Why it is deleting? 3D, join, yes, and join the columns, the cluster. Yeah, fine. Okay. Yes. So now it is perfect. So now if I just select this particular beams external wall 9 inch plaster, and if I just say that isolate category, then what you notice, I just hide this particular walls. Then what you notice that it will read and quantify only the plaster that has been wrapped that particular beams. Okay. Also this, I'll just press H8, and just like that, this ground beam external plaster 9 inch, which will wrap the plaster only on the outside. So see, this was the perfection I was talking about. If you don't work with this perfection in Revit, then there is no point of Revit, and this will perfectly schedule and quantify the plaster layer, excluding the masonry work. And just like same way, it will exactly quantify and schedule this masonry work, the walls. Okay, so this is the perfection you have to achieve. Fine. Now real quick, I'll just go to print level and real quickly, absolutely fast, I will just go to this particular section, and at all the intermediate sections, what I need to do is that join and switch order, and let the masonry go to the beam top, join join this, switch order. Okay, and here it is perfect, absolutely perfect. Coping, PCC, and masonry. Fine. Okay, we have not reached that particular. Come to this, join 1 to 2, 1 to 2, and 1 to 2, and just switch order. Or can't cut joint elements. Undo, join, and I'm just asking to switch order, my dear. Hmm. What is the problem? Anyways, let's just ignore it for now and just concentrate on the modeling part. I will just I don't want to. Yeah, see here too. I guess that we need to snap it to this particular thing, and this should have the base offset of 5.5, I guess. Yes, yes, perfect. And then join this to this. Fine. But why is it not? Oh, okay. It is a continuous flow. So what we need to do, we need to go to plane 7, edit boundary, and just snap it to this masonry line, not the plaster line, and this masonry line. Join this to this to this. Uh-oh. Split. Join this to this. Yes. Join, yes. Okay. And finish. And now if I just go to section, then if I just select this particular join in which order, and if I select this, you can't come and join. Yeah, that's fine. And join again. But with that, I don't know that why is it creating problem. Mm, okay, fine. Let's ignore this particular one wall for now. I just sort it out and get back to you later. Fine. And now just come over here. Join. Join this to this. Switch order. See, this is working perfectly. I don't know what is that problem with one wall. I guess that I need to draw that wall again in order to make it get to work. This and this should this. Okay, fine. Length level and just come here. Join 1 to 2. Let's first quickly join 1 to 2, 1 to 2. Join switch order. This to this to this. Okay. Lens level. Come here. Join, and we'll not have a drop slab here even though it is a toilet. Why? Because this is the ground floor and have a filling over here. So no need to unnecessarily provide the drop slab and increase the costing of the project. We will do that for the levels above. I will show you how to deal with that. Fine. So join and join here. Join and join this. Can't cut join elements. Switch order and join. Yeah, fine. That's okay. Ignore this particular one area. And this join and join this to this. Switch order. And this is done. Just go to plane level and this is perfectly done. This is done. This is done. Okay, so this particular horizontal section has been worked out. What we just need to do, we need to now check the vertical sections. Okay, and just finish. I mean, take the section. This medium, fine. Okay, so this is not a problem. This is not an issue. Yes, here. Yes. So join this to this. Why is it not? Yes. Oh, yes. Sometimes Revit behaves weird. Join this to this. Because it is a one continuous flooring. So that's why it is cutting only this edge. It is not cutting this edge. See, when I select this, it is a one continuous flooring. Join, and here it might work. See, for some elements it does, so some it doesn't. So see, perfect. Mostly 1 to 2. Which order? Yes. Okay. So one is done. Now come over here. Because we have a column here and the wall changes from this part. Earlier we did this. So now this, yes, fine. Again, go to that particular section and join 1 to 2, 1 to 2, 1 to 2, 1 to 2, 1 to 2. Here everything is working absolutely perfect. Yes, switch order and let the masonry part come till the top of that beam, because the finished floor layers will be laid after on that particular. You here we are skirting, and then the finished floor layers will be laid. Okay, done. One more. This would be same. This I guess that we need to do. Here everything seems perfect and joined. That's great. Join and switch order. Perfect. And yes, plinth level, and just look at this particular one section. Very yes. So see, join and join this to this to this. Switch order. Okay, that's great, and we are done. Okay, so that is how we have successfully completed only up to this particular first floor. Now we need to lay the slab. This was PCC because it was ground floor. Now we need to lay the slab onto this particular first floor. Fine, so just try to follow. So what I will do, again I'll go to plinth level and I'll take this particular reference line, and we have a common point to lay. If this is the common point, move it's from here to here, WF, yes, not this, but okay, fine, this is. And what I'll do is that I'll just select this and say that edit work plane and snap to first floor and just click OK. So now I'll go to first floor. Okay, and herein we can't see anything. Oh, ceiling planning, sorry, floor plan, ceiling planning, floor plan, and here we are. Insert and import CAD, and just navigate to that particular location. BTS, live classes, March, April, basics, and first floor, and just click OK. Sorry, undo, redo, and insert, import CAD, and first floor, but don't forget to just change the settings, inch and manual center, and open, and just snap VG and imported categories, and here we have only this first floor plan, so apply and OK. Now where do we need to snap this? Plinth level and on this particular column. Fine, so what I will do, I will just say that modify and align this point to this point to this. By this we have perfectly snapped the AutoCAD plan and hide in category. Okay, and let me just select this particular, go to plinth level and select any of the wall, and just to cross check, if I just take this particular wall or this particular column, let me just select this rectangular column and let's take it to terrace plan, yes, and just see it in first floor. Right, so WF and yes, so see it is exactly snapping to perfectly same place. Okay, and just undo it. Okay, so fine. Now what we need to do, first we need to create the flooring. Okay, for which first will be the RCC, not PCC but RCC floor plate. Okay, so architecture and floor architecture, and this time just going to select this particular RCC floor, first floor RCC, just like we had PCC for ground floor. And we also have this first floor RCC, wherein the only difference is that since the PCC was placed on the ground floor, so there was no layer of plaster going to be visible when you see it from the level below, because it is ground. But this particular floor plate will have a layer of plaster, since the person standing on the ground floor shouldn't, the plinth level, the person standing on the plinth level shouldn't see the RCC slab casting. Okay, so I'm just going to select this particular thing, and real quick I'm just going to draw the boundary line, and boundary line pointing to this particular AutoCAD plan. and then we will deduct the lines of that particular plaster or whatever. Fine, and I'll just a little bit of drafting we'll have to do, but that's okay. Line and just okay, and yes, not here, but till this point, till extreme point, and all the way till this point, and from here to I guess that yes, this will be entirely, and we will have it here TR and TR, and we need to split lines. Join this to this, join this to this, and one more line from here to here, and that would join with this line. Okay, so this would be the floor plate, and we just need to deduct this because it will be a open space. Okay, with this I'll just say that finish and say that yeah, save project. And would you like to go to this floor level to attach its bottom? I'll say that don't attach. Fine. With this, if I'll go to 3D, then now we need to join some of the geometries. Fine. Very what you see is that there's columns. Yeah, so we need to switch order. So this is now going to be really switch, yes, and just select this column and switch, because column should go continuously till the last level. Okay, so we have our floor plate perfectly defined. Now we need to join certain common intersecting volumes. So join and select this particular floor plate, and we just need to deduct the plaster from some of the areas. See, here we have join and join this, yes, perfect. And with multiple join checked on, let me just check on multiple joins, and this will get rid of. Okay, and no, here we don't have anything. Yes, so here we have this particular plaster layer. Fine, so this will be deducted. We will also join this beam, but later we'll switch the order. Fine, so that's okay. Here, yes, this and this plaster layers. Okay, and also this walls, this wall, this and this. Okay, and here we have to define a drop that, and I'll show you that how to do that particular thing. But right now, we just click escape, CC and R enter, and we have left some of the portion. Let me join again, and this also should be deleted. Okay, fine. So just like we switch the order for the columns, we also need to switch the order for the beams. So what we'll do, I'll select this particular slab and one of the beam and say that isolate category. Okay, with this now, let me just check whether it is not cutting the volumes of the beam. Okay, perfect. Everything is perfect here. And yes, so this particular column needs to be switched order. Fine, and also this beam. So join and switch order and not column. HR, let me just see. HR, yes, and we have column there. Yes, fine. Okay, so join. Yes, okay, and HH, this column. Yeah, that's perfect. So HR. Fine, so no issues with that. We have casted slab of the first floor, but is it following the footprints? Yes, okay. So this is the bedroom, and yeah, fine. So now we need to have a couple of finished floor layers onto this particular thing. But before that, let me just create the drop slab for this particular washroom. And if I just take this particular section 1, then it should flush at beam bottom. It should flush at this point. Fine. So what I'll do, I will just say that again, I'll go to architecture and floor, And floor architecture, with that same first floor RCC, I'll just draw a simple rectangle from here till here, and likewise from here till this point. But I would say that, right, third flush here, yeah, fine. But I would say that the height offset should be -1 feet because it has a thickness of 6 inch. And just finish and don't attach. So now if you just watch this particular section, then what you see that the RCC slab is exactly putting up at this particular place. Okay. So now we need to modify and join this. Okay. Uh, beam external. Yes. So yeah. So we need to join this. Yes. Join or join this to this. Yeah, fine. It's joined. Okay. And likewise here too. So I'll again go to first floor and take a horizontal section. And what do you notice is that we have a lot of geometries to join here. And this is a little bit going to be tough to pursue for you guys, but just try to understand. I will just join this with this. Okay. And yes, also I'll join this to this. Okay. So that plaster layer is eradicated. And also I will join this to this. Okay. Right. Now, when we pasted the slab onto this particular first floor, there are certain areas where we need to host the beam. For example, this particular area. See, here we have the passage runway. So here there will be one beam. This all four, there will be one beam. Here there will be one beam supporting this particular slab. Okay. And likewise beams at a couple of places. Fine. Here I guess that already there is a beam. So what I need to do, I need to go to ceiling plan of plinth level. Okay, fine, perfect. And if I can see the floor plate hosted, fine. So what I will do is that I'll just change this particular view range up till, yeah, 9 feet. That's fine. Okay, so I can perfectly look at the. Okay, so this beam, fine, and here one beam will come. Here will be beam. Okay, so let's just quickly concrete rectangular beam 9 cross 18 and just say that CS. Pick a plane and pick on, say that I want to lay it on the first floor and just click OK. Fine. And I want on the first floor the bottom of that to be laid. No, sorry, the top of that should be laid. Fine. And if I just click from this point to this point, yes, but I'll just need to change the Y justification to left. Okay, perfect. And yes, no issues. And here too, I will have one beam CS and yes, an entire rectangle. I cannot draw the rectangle. That's fine. 1, 2, 3, and 4. But all of that I'll select and I press tab. So the beams drawn in chain will be selected and just set the Y justification to right. Okay, perfect. So now if I just go to 3D, so we have the beams hosted there. Fine. So again, we need to join and join this floor plate to this beam. This beam is not intersecting this particular beam. And where we laid the beam over here, CC or enter, plinth level. Okay, here we haven't laid the beam, but where the beam will come at this level here. Fine. So CS and just draw one. Okay. And the bottom of that should be laid, I guess. No, sorry. Top. Let's just check it in 3D. Yes. This particular floor plate has some of the issues. Yes. And this particular beam will act as the inverted beam for this particular drop slab. Fine. And I will just say that join and make this walls, or let's just say that select both of these walls and attach top base. Okay, and click OK. Fine. So that is excluded, that those walls will stop at this particular slab bottom. And what we need to do, we need to select this particular wall, and since this will be a beam which will be having uh, which will be inverted beam, and it will be having casted in a drop slab to this particular wall, the plaster layer, this particular beam wall will not come here. So I'll just delete that. Fine, delete. And also I will just say that join, and this column will stop at this level. Okay, CCR enter, and let me just say that select this particular column and attach top base and attach. Yes, conjoin and OK. That's fine. So we perfectly have this. Now I'll just say that isolate category, OK, and TR and join this to this. TR and join this to this. Yeah, perfect. HR and yes, right? So this is how you have defined the drop slab for that particular toilet portion. Fine. And the same way we need to do it here when this will be the inverted beam in this case. Fine. And I would again select this particular beam and say that isolate category, and I will in this case I guess that this will join here. Okay, HR. But as you saw, that beam was getting cut with this particular floor. So what I need to do, I need to switch order. HH, and yes, for both of these beams, I will select this and I will select this beam, and I will say that isolate category. Okay, and join and switch order. I'll select this beam and select this. Okay, so that is perfect. Fine. So HR, yes, and also this column, yeah, that column is fine. No issues with the column. And I will just say that hide in view by elements because I don't want to see the AutoCAD plan in 3D. And here is that particular drop slab, and we made a wrong connection for this particular beam. Actually, this beam was supposed to isolate category, and this beam should, no, yes, this should stop here. And here there should be one more beam which will be joined with this. So again, go to plinth level floor plan, and here will be that particular beam. Fine. So just concrete rectangular beam, just drag it and say that CS and draw from here to here and connect this 3D. Yes. So now it is absolutely perfect, and you don't have any issues and any errors. All the columns are also coming up, and all the beams are also coming up with the slab. Fine. So we just need to join the newly drawn this, join again and join this to this, join this to and this. Okay, now what we need to do, we need to switch the order. So switch and switch. Okay, that's absolutely perfect. And for this particular beam, we won't have the layer of plaster wrap since it is going to be the inverted beam which will be hidden in the drop slab. But before that, HR, and I will just say that this beam should have a switch order. So join and switch order with this. Yes, perfect. Okay, CCR enter. This is really going to be difficult for you guys to crack, but if you want to model with perfection, then you have to crack it and you have to try to understand this. Fine. So one more, I guess that isolate category, and yes, this particular beam should connect here, length level, and this particular beam should connect at this point. Absolutely perfect. Okay, 3D. Yes. So that is it. Perfect joint condition. Fine. And now I'll just get rid of this. And do we have any errors? Because since we're talking about graphing perfection, and there shouldn't be any error. Yes, the only thing is that this particular face should be wrapped with the layer of plaster. So again, I have to select this particular beam wall and CS and pick lines and snap to the center. Yes, and this. Okay, and I will just say that while going to 10th level, I'll just switch the order. Yes, and I'll just actually we can just connect this. Fine. But with that, now I will just say that um, join this, press structural framing with this, and this to this. Yes, CC connector, join, and join this beam, structural framing with that. Yes, okay. Then we lost this connection. See, this is how time consuming it is, but it is worth it. Mm, yeah, it is there. Sorry. The visual graphics made me think that it was not there, but it was there. Fine. And here is that particular beam. Yes. Okay. And what we just need to do, join and select the particular floor plate. And this was here. Join and get rid of plaster and just join and yes. Okay. Here too. Join and with multiple join and check. Yes. And also this again, this will be in the drop slab. So you need to select the another wall which doesn't have the plaster on that side. Yes. So which wall will you select? This ground level beam external plaster, which will have the plaster only on this exterior face. Okay, so we need to go to, we just flip the direction and move it from this point to this point, or this point to this point. Likewise, just flip the direction and move this end to this end and join this to this. Oh, sorry. Yes, and go to 3D. Yeah, this is perfect. Sorry guys, I made a little mistake. So deeply sorry for that. Yeah. Okay. 3D. Join and join this to this. Join this to this. Okay. Actually, this beam should extend till this particular. Yeah. So fine. Sorry. Sorry once again, and just say that isolate category and this beam. So let's go to top elevation here itself in 3D, and this should connect. This particular thing should connect to here. Okay, but the finished layer of plaster here would be, because this particular portion is going to be visible from inside also. Fine. So what we will do, we will not post this particular ground beam external wall plaster, but this two-way plasters. Okay, concrete rectangular beam and this particular beam external 9-inch wall, and just say that CS, or select that particular thing and CS and pick lines and post it here. Okay, and just finish and go to plinth level and just stop it at this point. Yeah, fine. Go to 3D. I'm just going to join and join this. Okay, and also I'm going to join and get rid of this plus. Okay, so just like that. Don't worry about this internal plaster line at this particular drop slab. We will just get rid of it in section when we design this particular drop slab. Fine. But now, since we laid this particular beams, this beam and yeah, this particular beams, this four beams that will be visible from the lower floor. So what I need to do is that I need to wrap it with the layer of plaster as well. So I'll just select this particular beam wall external plaster CS, and I'll just draw from here to here, and I'll just say that rectangle, and with core face exterior I'll draw from here to here. That's perfect. And go to 3D and just join. Yes, and also join the floor plate. Join and able to select the floor plate. Okay, let's just first join the yes and the beams with the walls. Yes, yes. Okay, and now once done that, now we need to exclude the layer of plaster. So here too, I guess that something is yes. Okay, and now with this particular just this so that we can select this floor plate, join, and just get rid of the plaster. So with that join and multiple join checked on, 1 and 2, 3, and yes, it's done. Fine. So HR. And now if you one thing I forgot. Again, undo and join. Undo again. Draw. Yes. So join and with multiple join checked on. 1, 2, 3, and this one. Yes. Join and join this to this. Okay. Fine. So that has been excluded. See? HR. So a lot of hard work, but that is worth it. Fine. So now we are going to lay the finished floor layers onto this particular first floor. Fine. For which first we will lay this particular bedroom and this particular HL, and why is that? I can see the AutoCAD plan, first floor drawing. Yes, doesn't matter, but we will create this. So architecture and floor architecture, and first will be this particular fourth floor circulation areas. Fine, which pertains to this particular area. Okay, this entire chunk, and height offset from level 51 and 50 level first floor, and the height offset from level 51. Why? Because the finished flooring layer is 51 mm. See, if I just go to edit type and edit, then if you calculate this sand bedding 20 mm, mortar 12 mm, and finish flooring that is 19 mm. Okay, all this rounds up to 51 mm, which will be laid on that particular RCC slab casted. Fine. So if I just click this boundary and just define that circulation areas. So from here it will be from this point and also this point. I'll get rid of this, and that's enough. I guess that I need to split lines, split and join this to this, join this to this, and we have this extras which I need to get rid of. Yes, okay. And here I need to flush this particular to that this line. This should flush here. Okay, so that would make up finish and don't attach. And just go to 3D, CC, R enter, and yes. So these are the public areas. Fine. Okay, which are having this particular 51 mm of offset. But I guess that this particular face should be selected, and I got confused with the AutoCAD plan. Yes, so this is that 1 and 2 3 and 4. Just finish and don't attach. And now let me just go to 3D. And yeah, fine. So now that's perfect. Okay, likewise, we need to say that CS and first floor public areas, fine. So that pertains to the bedroom areas. So just create a simple rectangle for both the bedrooms. Okay, and just finish with a height offset of 51 mm. That's perfect. Okay, and then say that CS and first floor private and rectangle, and it is also having 51 mm thickness. So just say that rectangle and create one, and here two. What's wrong? And create here as well 3. I guess that's, let's snap to the internal of that particular beam and line, and just draw from here to here, trim this, join this to this. Okay, and just finish. What is the problem? Lines cannot intersect. Continue. Okay, there are 2 lines, and just finish. Don't attach. Yes, and just go to that particular 3D. So perfect. Okay, absolutely perfect. And here there will be a wall, so don't need to worry about it. Actually, we should have, while going to first layer, we should have snapped to this internal face of that AutoCAD plan. But this is UN, and just turn this to feet and fractional inches, rounding up to 1/4 of an inch. Okay, and okay, and just measure this. Oh, this is 9 inches, so this should actually be the snap line. Why are showing this unnecessarily so many lines? So I guess that for as per the AutoCAD plan, yeah, this is perfect. Okay, so we'll go as per the AutoCAD plan. Yeah, fine. Okay, so now the last thing remaining for this particular floor is that we need to create the finished levels, finished flooring for this particular washroom, that is toiletry, and that is really tricky again. So what I will do is that I'll just make you explain while going to 3D of this particular complete project. And if I just go to this particular plinth level working, and if I just take a section from here, then what do you notice? That this is the drop slab. Fine, this is the drop slab, and these are the finished flooring layers onto that particular first floor washroom floor plate. And if I just go to edit type and edit, then these are the different finished flooring layers of that particular floor, of that particular area. And if I just turn this to millimeters, 0, 0, okay, and you see that if I just go to edit type and edit, so this is the mathematical calculation depending upon height which we guessed, in order to have one tile drop between the finished flooring, the flooring which is next to it. For example, if I just take this particular section, and if I just show here, then this is the one tile drop. Okay, here there is the one tile drop. So you have to calculate that from this particular slab, what is the distance till this particular line, and then calculate. And I have calculated likewise, and with that I have been able to achieve this brick beds 290, and then rest everything same. The sand bedding 20, mortar 12, and plinth finished flooring 12. So this same floor we are going to lay here with this offset, height offset from level equal to 29.2. Okay, so that I'll just show you that how to create that thing. So let me just go to first floor again and CS, and we already have that particular floor defined. First floor washroom floor plate, and just go to edit type and edit. These are the same layers which I just made you understand. So just click the rectangle and draw it from this point to this point, and just finish and don't attach. But if you go to this particular, and you see that it has been perfectly laid, only thing is that we need to flush it with this RCC slab. So select this and flush. Okay, So still we have a one tile drop. And if I just go to UN and switch the units from feet and fractional inches to millimeters, okay, then you'll be able to visualize this. See, brick beds 290 and rest everything the same. Okay, and here the finished flooring is not 19 mm but 12 mm tile, so that we can have a drop slab, one tile difference between this and this area. Okay, wet area then dry areas. Now, as I said, that we will get rid of the external plaster from this particular wall. So here comes the time that I will just say that, but before that, I just like to edit boundary and go to first floor plan and draw that same here as well. So I will just draw it from this end to this end and just finish and don't attach. So I will just go to this particular section 1 and join this to this, join this to this. Okay, so that layer of plaster has been eradicated and it's gone. Fine. So again, plinth level, oh sorry, first floor, and now we will come to this particular section wherein you see that this is the, oh, this is really going to be tough to crack because first floor plan, and according to the floor plan, why the drop slab has been created all the way till this point, then this should come till here, but AutoCAD plan says something else. R enter. Yes, so see, mm, I need to check this particular thing in this. I'll just select this column and beam and this particular floor and say that isolate category, and let's just check this out. Yeah, fine. So you see that till this point is the finished floor layer. If I just go to edit boundary and go to first floor, yeah, it's perfectly to here, snap until here, then what is the issue? No. Don't attach, yes. 3. And here just to this point. Okay, let's just go to our floor plan and just look at this section, and where is the problem? Oh, here there will be a wall. Yeah, fine. So which will, so that actually, yes, I got it. Sorry, sir. Sorry, guys. So first floor and this particular line will snap till this point. Yes, and with that finish and don't attach. Yeah. So this is really, yeah, fine. So absolutely perfect. And this is the, see, this is the one tile drop which I was talking about. Okay, but now we need to join this in such a way. So very carefully join, select this beam and join it. And one element is completely inside another. Okay. So join this to this. Okay. Fine. And just say that join and switch order and select this until, yeah, fine. Okay, so that is how we have this inverted beam with this particular drop slab and the layers of that particular washroom. Fine, with one tile drop. Perfect. Um, what is this? I guess this is first floor public areas, and this is also to be created that particular floor 2 times. So just go to 3D and let's say that HR, and just go to section 2 again and select this and come to 3D HI. Okay, we have created that 2 times. Okay, and section 2 and select this and again go to 3D HI, and yes, see, we need to select this and just delete it HR. Okay, fine. So with this, now we will start laying the walls. Okay, but before that, first we need to select the columns SA, and all that particular columns will go from footing top to step by step we will move terrace plan. Okay, and with that I'll just select this particular SA, this rectangular column, and that too, I will snap it to terrace plan. You see, once that particular established, we don't have to do that again and again. Okay, and since we had made this join, we had joined this particular thing, so it is not. I'll just delete that particular thing and create that once again. Let's say that CS and go to plinth level. I will just create one. Okay, and I'll just go to 3D and snap it to terrace plan. Yes, it's not flat top, but terrace plan. Okay, I'll just join this particular rectangular column to this wall. Okay, but that's incorrectly joined. So join again and structural column, not rectangular column, but structural column to rectangular column. Fine. And this is also left. Somehow we missed it. So yes, join, select, press tab, structural column, the architectural. Yes, CCR enter. But now what important is that to join this particular thing in section, and that is going to be really tricky. Okay, so just try to follow. So if I'll just go to section 2, and if I just take this above, then what do you notice? Where is that particular section? Yes, so I'll just take this particular section, cutting this column, and just go to that particular section. Fine, so now the joining of this is going to be really hard. Okay, so we need to follow some, patiently do it, and join this to this. Okay, at least this is done. Then next is that we need to join this particular thing to this, but then we need to switch order. Okay, okay, only thing is that this particular thing now continuously needs to go up. So switch order, select this column, but first is that we need to join this to this, and then switch order, select this beam and this. Oh, sorry, we are almost there. Just try to follow. Select this column, and yes, okay, so this is how you perfectly join. See, this particular line is the level line. Fine, so if I just hide this, and you see the perfection, H, yeah, see, perfection, how to join geometries in Revit H5. Fine, so just like that, I'll go to first floor, and I will come to this section wherein this we already did, right? Fine, first we did that, and then we went to that particular area. Okay, so now we are completely done with the laying of this. It was a tough job and hard time, but fine. Okay, learning process are always difficult. Okay, so now we need to elevate the walls further from this particular level. Let me just close all this unnecessary views. Just go to first floor. But not ceiling plan of first floor, but floor plan of that particular floor. Okay, and we have to snap the walls. Okay, so let's just quickly do that. So I'm just going to say that WA and main wall 9 inch. Where is the main wall 9 inch? Yes. And so it's difficult to visualize. So UN and MM, and let's turn it to feet and fraction inches, nearing up to 1/4 of an inch. So the precision of AutoCAD, nearing up to. Okay, so WA and that with that main wall line is selected. Core face exterior first floor, and just get rid of this base offset. Okay, and fill terrace level plan and no top offset. But no, there will be top offset because of the beams. And how much? 1 foot 6 inches or 5.5 inches, I guess. Yes, so that will make this 8 foot 6 inches or 1 foot 6.5, I guess. Yes, that will make it 8 foot 5.5. Okay, and that will finish core face exterior. I'll just draw this walls from here to here, and here we just change this to course. I mean fine, so we can Okay, and this would be continuous L-shaped wall, and this wall will only, and I already explained you the purpose of drawing wall this ways in order to properly quantify. Okay, so yes, and this I guess should connect here. Yeah, that's fine, perfect. CS and this place it here, and now we will have a continuous C1, and this will be, oh, this wall at this particular level will be continuous. Just finish. We need to flush it and say CS, press space, and just move it to this point. And here we will have internal walls, but before that, let me just create this too. And from here to here, and from here to press space and flip the direction here. Okay, and from this point to this particular point. Every wall should be unique. Each and every wall should be unique. Fine, and then just say that WA, and here also there will be, yeah, sorry, here also there will be the wall which we are going to edit in order to have the curtain wall there. And just flip, just line. Okay. Only thing is that WA, and here we don't have wall. Why is this? Yeah, that is a beam. Okay, so with that finished flooring, where is the finished floor gone? Oh, because of the type of it, we can't see it. The fourth floor, and let me just check the view range. View range, and yeah, 4 feet, 7 feet. Why is that we're not able to see the finished flooring? Okay, it is hidden. Sorry. Absolutely sorry, that was hidden. So that's why we're not able to visualize that. Okay. So CS, and again, just draw it from this point to this point. Okay. And now, yes, the internals. So that will be here. I guess that this is a continuous floor plate which doesn't have a balcony. Why did I draw on the balcony over here? HL. Just snap it to this and just get rid of this particular thing. So finish and don't attach. And this would be edit boundary. Snap it to this point. Yes, and just finish. Yes, okay. R enter. Yeah, that's better. Also, we need to draw the wall over here. So I'll just say that CS, but this would have the unconnected height only of 9 inch, which will act as a skirting, or 6 inches also enough. Let's make it 9 inch. And we will draw it from this point and connect to this point. Okay, and the same CS will be drawn from this to this and entirely this HL. Just flip the direction. Okay, perfect. Fine. And with this, I'll just say that R enter. Yeah, that's perfect. Let's see it in 3D. Okay. Right, and this column will end here. So just make that snap to first floor and unjoin OK, and this too will snap to first floor. OK, and let me just select this and this beam, column and beam, and just say that isolate category. And yeah, that's perfect, absolutely perfect. Fine, we don't have any issues. HR. I forgot to lay the tie beams. Here there will be tie beams which will stop the buckling of this particular, but that is very simple. Just need to go to that particular level and define a type and just lay the beams. Okay, so that is easy. There's no rocket science in that. I'll just show you. See, here is these are the tie beams. HR, and yes, these are the tie beams which I'm actually not sure that will it come at this level or will it come at this level. I suppose that will come at this particular level. Fine, but I'm just considering an ideal situation. Okay, so now what is next is that we need to create two internal walls, first floor and WA, and just select internal wall 9-inch, first floor and terrace level. Yes, terrace level and unconnected height minus. Okay, and that would connect from here to this point and here to this point. Okay, well, let's just see it in section. What we will do, we will join it and join this to this and just switch order, bring this down. Okay, and one face will not. Okay, that's okay. So first floor, and just like that, you need to adjust this particular thing. Okay, and join this to this, this to this. There is already highlighted elements are joined but not intersect. Join and this. Okay. Oh yes, so multiple join is checked on, I guess. This has been laid incorrectly. Okay. Join and join this to this. Fine. And just switch order. Yes. And here we will have glass railing. Join and switch order. Okay. Perfect. Fine. So with that, now we just need to connect the beams at this particular first floor level. Fine, we need to have the connecting beams. So how will we do that? Very smartly, I will just go to this particular thing and say that isolate category. So not height category, isolate category. And then very smartly, what I will do is that I'll just select all of this, copy to clipboard, paste align to selected levels, and I will just snap it to terrace plan and OK. Right? With that HR, and you can do the required changes if you want. For example, this you won't have, delete all this you won't have, and yes, you will have this beam. That's okay. Also, this beam you will have. Yeah, that's fine. All of these beams you will have. Fine. This wall I forgot. First floor. CS. Yes, I forgot this wall. You don't need to worry about this plaster layer because the material with same, the elements with same material will automatically join. So this wall will join with this external plaster, right? Because both of the material are same. Visually, I guess that there is a problem for this particular one wall. We just go to section 2, not section 2, but I guess that's section 3. Yes. And yeah, see, so this particular wall has placed wrongly. Okay, and with this now it has a flush connection. Okay, perfect. So now let's go to 3D and also this particular one beam. I know why is it floating like this here somewhere. So I just go to this section, then this beam is makes sense here because we have a wall, 9-inch wall. But here, I guess that it should be moved to this face, and this wall should move here. Okay, and fine, that's okay. So with that, now we'll just go to first floor, and we have a little bit of change in the flooring. So this HL, finish, don't attach, and edit boundary. So it is not responding to the AutoCAD plan, because as per the AutoCAD plan, the wall should be here. But I feel that this particular thing is not appropriate, so that's why I shifted the beam. Okay, so now what we need to do, we need to join the beams and this columns, rectangular columns, structural columns, and the beams. So I'll select this concrete columns, this column, and the beam. I'll say that isolate category. Fine. And with that, real quick, I'll say that join this to, yes, just get rid of the extra plaster. Fine. Okay. Okay. And simply perfect. I guess that this column also needs to be, you see, R enter, join, and oh no, that was proper. Yeah, this is proper. But then why is it appearing like this? We have adjacent wall, I guess, so that's why it is not joined with that. So that's why it is appearing like that. That's fine. Forget it. And now just join and okay, this perfect. 1, 2, yes. Take good get rid of this. Here, this should be okay, getting rid of extra plasters. It will eventually hide the quantification and costing. So with that, now let's just press HR, and what we need to do, we have joined this particular column with that particular plaster layer to this particular beam, but we need to again say that this particular exposed beams should be applied the material of plaster. Fine. So that beam wall, the same wall we created here, beam external 9-inch wall, I'm just going to press SA. It will select all of them, and HR. Yeah, fine. Only so much of them are there. Fine. And what I will do, SA, and oh, that this one. Select, yeah, beams external 9-inch wall plaster SA. Copy to clipboard and paste align to selected levels, and just snap it to terrace plan. Okay, but SA, which snap it to first floor. It has been, yeah, see, perfect. Okay, so what we just need, we need to join it, otherwise it's perfect. PR and join this to this. Okay, perfect. For this, I need to go to terrace plan of first floor, ceiling plan of first floor, in order to visualize that, and just change this particular view range to 18 feet, my god. 9 feet, 9 feet cut plane. Okay, just hide this grid lines, hide category. Okay, so let's see that why it is not this. This should snap here itself. And join this to this. Yeah, fine, absolutely perfect. Okay, but I'll just turn on this fine. And what do you notice that we need to join it? Okay, and at some places it doesn't, so we need to continue that. It was at that particular level, there was no need, so that's why it is not reflected. But here at this level, it is needed. So I'll just again go to first floor, reflect the ceiling plan of first floor. Yes, and this I will just join to this. Okay, perfect. And this I will extend here, but all the way to this point. Yeah. Okay. Uh, this wall. Yeah, we forgot to shift it here. We shifted the beam, but forgot to shift this. So this should be the snap point. So this should move here, and this should be the snap point. Yes. Okay. But there are a lot of things to be joined. Okay, so we'll just try that in 3D itself. Let's select the structural framing and structural framing. Yes. We separately had to assign the layer of plaster to this wall because on this particular first floor level, those were in sunken slab. Okay, so that's why we didn't apply the plaster. And when we copied here, it appeared without plaster. So that's why we have to apply plaster differently for this particular beams. Okay, and join and let's quickly join this all. Join and join this. Oh, first, sorry. Here, the beam might, yes, and that now, that's okay. You have to be very precise while modeling, you see. Now the tutor is facing so many problems, you see. So the tenfold of that you are going to face when you will model. Right? And yes. Okay. And this too again is not reaching PC or enter. No, this. Oh, it's not. It was not. Let that. Press tab, structural framing, and oh, come on. Yes. Okay. And again, this color change to neon fade. Anyway, not important. Yes, and perfect. See, good. Okay. Also, this design is not reaching. Also, we need to wrap the layer of plaster to the beam. Here there will be a wall actually. That's why I'll just press space, select all of that. 1, 2, 3, 4. We don't need that this particular level. Okay, and what we just need is, let me just go to first floor. Oh, it changed to this theme, so that's why. Yes, fine. Okay. I'll just change this particular, take this particular section here. H12 and CS, and that should be a wall here as well. Section 2, section 3, sorry. And yes. Okay. We need to join it in plan, but we'll do that later. Right now, first let me just complete with this. So CS and first floor and direct plan of first floor. Yes. CS and 1, 2, 1, 2, 2. Yes, and you see in 3D, modify and join. Yes, absolutely perfect. No issues. Fine. This, if you want, you can make it 8 foot 16. No, sorry. This could actually, yes, join geometry and join. Fine. Okay. And here also there will be a beam, I suppose. Yes, of course. So let me just take this beam and copy from this point to this point. Let's go to 3D. Okay, no issues. Join this. This needs to be joined and then right here. So we don't have any issues now. For the first floor should also have this CS and join this to this. Press flip. Okay, let's go to 3D. Yeah, fine. Okay, so now we can lay the floor plate for the terrace level. Okay, so I'll just close this all this unnecessary views. And herein, I will just say that LI take a reference point, move it from here to here. Okay, WF, yes, and make that particular point edit work plane and go to terrace level, terrace plan. Yeah, fine. And just go to terrace level, terrace plan, and here is that line. So what I'll do, I'll just go to insert, not load family, import CAD, desktop, PTS, live classes, and we have this terrace plan, yes, inch, manual center, open. Oh, there is some mistake in imports. Yes, import unit should be inch. Yeah, with that just select terrace plan and open. Yes, just place it. VG, import categories and terrace plan turn to halftone, DWG drawing, and then modify and snap this to this and this to this. Fine, so that is how we have snapped the terrace floor plan over here, and just hide category, but not with this. Right click and hide by category. Okay, and let me just see the range level and base level to first floor. CC, yeah, CC. We can just see the floor level. Okay, that would be more confusing. Let me just press undo and only have the AutoCAD plan. Okay, so let's say that architecture and floor architecture. This time I'm just going to select terrace RCC, terrace floor RCCC is there, 6.5, the same way that particular family has been designed. And just snap from here to here, here to here, this to this. Okay, and I guess that externals should have been clicked, but that's okay. Just snap it to interiors. Yes, fine, and just finish. Don't attach. Okay. With this, now what needs to be done? First is that age and only couple of, but this time you are going to use a different method in order to join this particular geometries. For the first floor plan, we wasted a lot of time. So instead, what I prefer is that you just go to this particular section, and from here in, just this is having top height offset, also just change 0, and just modify, join this to this, join this to this, join this to this, and switch order. This is much easier way than we did it in 3D for that entire first floor, because I forgot this method. So that's why. But this is more easier method. Fine. Doing it in section. Okay. And likewise, now I'll just go to this terrace plan and hit this section. This section is done. Yeah, that's fine. I'll just hit this particular section. Okay, and just join it. So first join this to this, then join this to this, and switch order. Perfect. Join this to join this to this to this, and switch order. Working in section is much easier method than 3D. In 3D we wasted a lot of time for that particular first floor. Got this method. Pardon me for that. Yes, and if I just go to 3D, then we have a couple of still more geometries to be joined. Let's go to terrace level. Take this section here. Here, which we have done. Yeah, so join. Yes, this is done. Take it here. We have done that. Take it here. This is also a join. Join this to this. Join this to this. And switch order. Switch order. Switch order. Let's do this. Yeah. Now I'll be real quick, because I hope that you guys understood the concept. Okay. Let me just hide in view by category and go to terrace plan again. Let's take this section here. Join and this to this. With order. This to this. With order. Yes. Join. Yeah. Perfect. Okay. So terrace plan, and we already have this white. Which order? But not least. Yeah. Okay. Now we will shift this here. Horizontal and vertical section at intermediate level. With order. Why is this? Which order? Yes, perfect. this plan and get over here. Let I guess that everything is joined perfectly. Get back to this location. Everything seems perfect. Get back to this location. No issues. And finally, over here. Yeah, especially this is the main. Okay, perfect. Now we'll go 3D. And what we just need to do, yeah, to join everything. What we just need to do is that we need to join this plaster layer with that slab. So what I will do, I will select this particular channel beam plaster and select this entire and say that HI. Oh, sorry. Can I not select this particular floor plate? CCR enter. How to select? Let's select it from here. H8. No, what? That will also be hidden. But that's okay. If that is hidden, then not good. So select this and select this. Or instead, just quickly, real quick, just say that join, and with multiple join checked on, just select this. And wherever you need a feel of joining that plaster layer, just do the needful. We joined the wrong, but we just switch order, doesn't matter. So see, everything is perfect. CCR enter. No, it's perfect. So just join switch order. Yeah. Okay. CCR enter. Join this to this. Okay. Switch order. This to this. Okay. CCR enter. Oh, the last moment creating a problem. Yeah, there must be a column. So join switch order. Select that column and select this roof. Yeah, fine. Absolutely perfect. Yeah. So all these are columns. That's fine. Join and that's okay. Yes. Okay. So join. Eight. Wow. Fine. Now what we need to do? We need to select the columns in this area. Okay. All those six columns are selected, and just say that the laptop will be the last level. Fine. And with that, the structural concrete rectangular beam, I select category, select 1, 2, 3, and 4. and just copy to clipboard, paste, align to selected levels to slab top. Yes, and just trim and get rid of the unnecessary. Fine, and it's HR. See how perfect. Okay, and here there is no column, so that's fine. And for this, proceeding further, we need to lay the finished flooring of this particular terrace level. So R enter, and I hope that this already designed architecture and floor architecture, terrace floor, finished flooring, terrace, terrace finished flooring. Fine. Edit type and edit, and you see that brick beds for waterproofing since it is terrace, and then all the same layers. This is 20. This is 100 mm. This is 20 mm. This is 12 mm, and this is 19 mm. Terrace finished flooring. This material has been applied. Okay, so this 8L boundary line from here to here, and complete here to here. This finish. Don't attach. Height offset 0, and should be given how much UN, length, millimeters, rounding up to 0 decimal places, modify and measure from this point to this point 152, and just give it a height offset of 151, I guess 151. Yes, absolutely perfect. So if I just take you to one thing I forgot to show you, that how I have designed this particular materials. So this is nothing but it's this is the JPEG image that has been applied. But if you just go to graphics, then it doesn't have foreground pattern, and the cut pattern is this sentence. So just like that, mortar. This doesn't have any appearance because it's not going to be seen, and it will have this cut pattern of gypsum plaster and foreground pattern to none. And just like that, this particular brick beds is having brick beds. Appearance is nothing, but the graphics pattern, foreground cut pattern of this particular brick, which I have loaded from CAD. Okay, and this is nothing. Fine. Only the sand bedding PCC has been given this material because I don't remember right now. Otherwise, this also should be in the default state only. That was the reason why I signed this JPEG image to that particular material. Otherwise, was not needed. Okay, fine. So just let's go to 3D. Wow, that particular finished flooring has been laid. Okay, and what we need to do? We need to first create the walls at particular this terrace level. So just go to terrace plan and WA terrace plan and unconnected name, but slab top. Okay, and 0. Let me just change the UN and to feet and fractional inches, then nearing up to 1/4 of an inch. Okay, just create. Okay, right. Going. Again, I forgot. I was actually supposed to snap it to this point. Sorry. CS from here to here. Every wall should be unique, and every wall should have its own individual identity. Yes. Reason being, you'll be able to properly schedule and quantify the quantity for masonry work. Yeah, enjoying this a bit. Yeah, that's fine. Okay. Now just go to 3D, and I suppose that the particular columns already have that this and this. Let's say that isolate category. Okay. And with this, we can just take this particular, for this 6 columns, we can just take this all the way till flat top. Perfect. HR. Whenever necessary, we can just join them. But right now forces that we need to join this CC. CC. Oh, too fast. Speed. Okay. And this walls SA. Press one wall and press tab. That will select all the walls drawn in blue. Or enter. And this should also be transparent. Select 1, 2, 3, 4. Oh, sorry, not this, but oh, come on. Yes, 1, 2, 3, 4, 5. All of this flat top offset minus 1 foot 6 inches. Yes, minus. Okay. No issues. Fine. And then just again go to ceiling plan of perishable and change this view range to 8 foot, or let's say 9 foot and 9 foot. Okay, until we see this. Okay, not main wall, but WA and beam wall external plaster 9 inch, and this should be 8 foot 5.5 or 8 foot 6 inch, and rectangle again, not rectangle. No, but here we can have rectangle. The reason being, we just need to calculate the quantity of plaster. So WA, and let's not waste time. 1 and 2, 3 and 4. Right. Like, you're going wrong. Maybe, and delete this as well. See here. 1, 2, 3 and 4. Lowest wall created a problem. That's fine. And go to 3D and real quick join. join and uncheck multiple join, but in this case it won't work. Great, perfectly done. Come to terrace level and ceiling plan, floor plan of terrace level. And WA, say that 0 and unconnected height 3 feet. That would be parapet wall. Okay, and with the direction 1, 2, 3. 1, 2, and 3. 3D, and yes. Okay, and finally the slab top. So I just go to the particular slab top floor plan. We cannot see anything. That's okay. Just go to the particular range level, and with that, I'll just say that have a look of terrace plan, floor and floor architecture, and again terrace floor RCC. It should snap to this lines. Finish, don't patch, and then again floor. This time terrace finish flooring. And yes, height offset. Finish. Don't attach. Just pick a section from there. Okay, and all this walls 1 and 2. And just give it a height offset. Or we can, what we can do, we can just say that wall, and not this wall but main wall. This laptop and connected height of 15 inches. Why is this rectangle not working? Hmm. Okay, okay, simply perfect. Fine, and this HH, or go to section 4. Both of these are overlapping. So just give it a height offset of how much? With 0, it will be this. But this also should be 0, and this should be 151 mm. Yes. No, not that. This one. Finished flooring, 151 mm. Absolutely perfect. Modify, join this to this, join this to this, and join this to this, and likewise this particular section. Okay, fine. So now, before proceeding further, what we need to do is that we need to go to the floor plans and just check at various intermediate levels and junctions, whether we have modeled the entire geometry properly or not. Fine. So what I'll do is that I'll just go to this particular plinth level floor plan. Fine. And here we will take the sections at intermediate distance in order to just check whether the said geometry is perfectly modeled or not. Fine. So one horizontals and one vertical. Fine. So let's go to this particular section and start. Have a cross check. So herein you are going to encounter a lot of flaws which we need to correct. For that, let me just say that hide in view by category, because we don't need to see those red lines. And wherever you find geometry not properly joined or modeled, you need to correct that. Okay, and you see that here there is a drop slab and this still needs to be joined. Okay, this is the drop slab. So what I'll do is that first I'll select this column and join. With that, I will say that switch order. And yes, and join this to, join this column with slab. Okay, fine, so this is perfect now. See, this is the precision you need to work with in Revit. Absolutely perfect and no issues. Fine. Go to plinth level and shift the section a bit. Just join. This is not joined. This two and okay. Shifting the section in order to cross check whether geometries are perfectly joined or not, in order to properly schedule and quantify. Yes, to see here, this will switch order since the masonry will connect with the slab. Okay, and then there will be finished layers here also. It is. So now it's creating problem. Join and join this to this. Can't cut joined elements. Okay. So let's unjoin and now join it. No. So let's go to edit boundary, and which floor is this? First floor. So edit boundary and go to floor plan of first floor. And yes. Yes, here it is, I guess. No, this portion, yes, this portion. And do an attach. And now, if I just join and join, first floor and HL, okay. Once again, not modify sub-element, sorry. Click undo and edit boundary. Again, go to first floor. So what is the issue? HL. Not attach and go to section 1. Yeah, that's fine. So look at how you rectify errors and flaws within your geometry. This is not, yes. Here it is perfect. Here, everything is perfect. Plane 7. Let's shift it here. Oh, no, but that's the same section. Yes, so see here. But that is not cutting. Yeah, fine. So that is not cutting, so that's why it's doing that. This is, yeah, so it is not getting back. So that's why it is perfect. Let's shift it here. Just check. Yeah. Right. This is an awkward junction. That's fine. You change it to 8 foot 5.5 and that will wrap. Yes. Okay. Here there is no, this same thing needs to be snapped here as well. Let's see that whether we can snap here. No, okay, fine. Let's forget this. Let it be invisible from this and we'll change it. Yes, join and join this part. This part. Okay. Join this to this. Join this to this. And let switch order. Okay. And join this to this. Okay. Perfect. Only thing is that this particular one beam. So we need to go to ceiling plan of plinth level. Yes. So see this beam is needs to be wrapped with the layer of plaster. So CS and but where is it going to be visible from? Oh, there. Only this end. So we need to say that CS and just click and finish and go to that particular section. Join. Select the beam spectral framing. This, yeah, perfect. See, absolutely perfect. No issues. Join. Just do this. Open. Yes, fine. Length level again. And come here. Yes, everything is perfect. I don't see any errors or flaws. Finally, we have done for the horizontal one. Join and join this to this. Yeah. Okay. So we are done with the horizontal ones. Now we need to go to the vertical segment. So starting from here, let's say that fine. And yes, this we just did a couple of minutes back. This was left. Also this join and switch order. The masonry should come till the slab. Likewise, join. Yes, perfect. Join. Yes. And doing the needful and the same that all the and switch order this to this. Yes, perfect. Okay, join. This is join, but this needs to be, and then switch order 1 to 2, 1 to 2. Perfect. Join. Yes, and join. Okay. I think that this level is perfectly already sorted out. So no issues. again plinth level, and just shift a bit. And I hope that everything is fine here. We just hide in view by category. It won't distract us while having a look. Yes, so see, this is the main. So join and switch order this to this. Yes. Okay, the rest everything is fine. Just join and this. It's length level. Again, shift it a bit. Okay, and this is not cutting, that's why it's fine. Length level, shift it a bit again. Yes, and everything this will be the same. There's no issues with the upper segment, but there are changes within the lower segment, so we get that. Yeah, that's perfectly done. So no issues. Okay, and the last one, and I guess that we already done that. Yeah. Okay. So see, just a minute. Okay. Okay. One and two just close. And with that, now we have to check that whatever we have modeled, whether it is perfect or not. So in order to do that, what are we supposed to do? We need to run a class friction test. Okay, let's see that have we followed the thing what was promised in beginning, that this particular modeling will follow the LOD, that is level of detail 400. So let's check that whether that thing has been implemented or not. So in order to run a class detection test in Revit itself, what you need to do is that you need to go to collaborate, and here is interference check. Okay, and run interference check. And what I will do, I'll just select the structural element, that is floors and the structural columns and structural framing. Okay, and here walls. Okay, and just click OK. So that will give you this particular interference report. Fine. So what we need to do, we need to check that where have we made mistake. So first is this floor, is to wall. So what I will do, I will just press HL and select. Let me just go to floor and wall, any one wall, and just say that I select category. Okay, so with that, I'll just say that I'll just expand this. So you see that as soon as I select this, it will highlight this. Fine. Both the elements, that is the terrace finished flooring, is having a class detection with this particular wall. See? Fine. So what, in order to rectify this, you need to go to terrace level plan. Okay. And you see that here is that point. So my section is already there. So I'll just click that particular section. So as soon as you click that section and click this, then this is the error. So we forgot to join here. That's why it is showing that error. I'll just go to modify and join this to this. Fine. And with that, if I just refresh, so that error is rectified. With that, I will just come again here. First floor washroom floor plate, and it is having class detection with main wall. So I'll just select this. So you see that first floor washroom, and I guess that problem is here. Fine. So what I'll do, I'll just go to first floor. I'll close this terrace plan, and I will go to first floor. Yes, and with that, I'll select that. Okay, and here is that problem, and I know that. Okay, so I'll just, while going to that section, I'll select this floor plate and this main wall. So see here, this geometry has been left to join. To join and join this to this and refresh. Fine. So with that, all the errors pertaining to structural floor, that is the floor slab and the walls, architectural walls, has been rectified. Now, next part is that just HR, and next is that structural columns with the wall. So you need to select any of the column, any of the structural column, and I hope that the structural column has been selected. Yes, fine. And then select any of the wall and say that I select category. Now this is going to be a little bit tough for you guys to understand since you are dealing. Many of you might be seeing this first time, but just try to follow. So walls and concrete rectangular column. So this is that particular column. Fine. It highlights that column, and this is the beam wall wherein it is having a problem, and it is in the ceiling plan of first floor. This is the first floor and ceiling plan of first floor. So I will very quickly navigate to that particular ceiling plan first floor. Okay, and as soon as I select that column, this is selected and this is the problem. Okay, so what we need to do, we need to take a section or already there, we just need to bring it to that location and just take that particular, see that section, and this will highlight that. Oh, okay, and this is that problem. So what is the problem? That we need to join this to this or switch order, I guess. So just very carefully select the column and this, yes. And also this one is popping up. Okay, select this and press tab, or let's say that join, select the column and this. Okay, we have refresh. So I guess that it will rectify two of them, and just unexpand and just refresh. Refreshing is, yeah, fine. Anyways, so one wherein this is the column and this is the wall. So here also there is a problem. So this wall needs to be flushed here. Okay, and with that, if I just refresh, then no, here is, it's going on adding the problem areas. Fine, so I'll just see that. Okay, so this is the first floor. Again, this with this. Okay, but how to check that? So I'll just go to this particular section and let's see. Yeah, so see here there is problem. So join this to this. Okay, and here it is joined. So this particular thing, yeah. So see, join and join this to this. Okay, this I guess need to be switched order. Select the B. Yes, fine. And join this to, or just take this particular wall, or join again, join this particular beam. No, oh, I made a mistake. Sorry. This was supposed to be taken up a level above 0.5 of an inch. It was a rectangular column. Yeah, fine. So join and join this to this. I guess that this error has been rectified. Let's go to collaborate, interference check. So last report, yes, refresh. Okay, that's gone. See, so now only the errors pertaining to the structural framing is left over. Okay, so we just need to do that. Okay, so in that case, I'm just going to press HR. Okay, and select any of the structural framing, that is the beam and the wall. Okay, and just say that isolate category. Okay, so now I'll just say that H, let me just turn it to HL so you guys can visualize. HL. Oh no, sorry, it is HL shaded. CC. Yes. Structural framing and three of them. So this is the structural concrete rectangular beam, and we need to find it. And this is again going to be difficult. Structural beam, which it is 9 inch cross 18 inch. Okay, let's find whether we can find this wall. Yes, here it is. So the structural framing will be here itself. I guess that we forgot. We made a mistake. We have not isolated the structural framing, but something else. So this is the structural framing, and this is the wall. And then I'll say that isolate category. Yeah, it is proper, I guess. So let's select this wall and this. Okay, yeah, here it is. So see, this is the wall and this is the beam. Okay, so where will you find it? It will be ceiling plan of first floor. So let me just go to ceiling plan of first floor again, and let me just click it. Okay, and this is the wall. Yes, so see, this is getting inserted. So what we need to do, we need to say that modify and join, or we just need to take this up. Yes, fine. With that, if I refresh, then only two of them are remaining. Structural beam concrete again. Let's find out where it is. Here, this side. Which is the wall? This is the wall. So let me just go to first floor, and we can find both of them here itself. So just take this particular vertical section here and go to that particular section and just click this, click this. Yeah, so this plaster layer needs to be get rid of. This to this. Refresh, and only one error is remaining for this modeling, for this model to be called a perfect model, perfectly modeled with precision and joint condition, wherein we can take out the exact quantities. Fine. So again, this is somewhere here where it is. Yeah. So this is it. We'll be able to visualize. Yes. Here, this particular fine. First floor pay. I mean, sorry. On the first floor, wherever you had kept this particular thing, it is colliding with this. Okay. So again, going to first floor. It's not terrace plan, but this time terrace plan of plinth level will be more appropriate plan to, yeah, see, and this is the wall. Okay, so we just need to take this section here and very quickly see join. And that is why I say that if from day one you concentrate on the modeling purpose, modeling process and perfection, if you achieve, and you don't have to do this every time. Join and this, uh, let me just click and yes, okay, and with that refresh. And the interference report says that we have zero error. Fine. Refresh updated interference listed. There are no errors for this particular model, and it is exactly modeled with perfect precision and perfect joint condition everywhere. What do I see this? HR, R enter, and no. Yes, those are the overlapping volumes of the same material. So just need to join this to this. Okay, done. Fine. So we are completely done. And now you can say that this particular 3D model has been, this G+3 residence has been perfectly modeled with perfect precision, which will give you the exact quantification of the elements. So with that, now you see the beauty of this particular built structure, one homogeneous surface, one uniform surface. Fine. So let's finish off this particular project by adding door windows to this, openings to this particular project, and let's complete the modeling. Fine, real quick. So first I'll go to this plinth level, and here I would say that DER door, and I have all the doors already ready. So this is going to snap here. Just give it a constraint of that ground floor. Okay, and WN window, wherein here we'll have the classical window. That window has not, I forgot to share that window. So let me just go to this particular option, sloping roof. Yes, and just open the particular window. Yes, and just edit family, and just load that into the project, our new project that we just modeled, and just host it to the walls. 1 and 2 and 3. Okay. While cutting it, you can control the cell height. Let's say that 15 inches from ground level. All three of them. 1, 2, 15 inches. Yes. You can later on decide its exact location. But right now, I'm just randomly placing it as I know the location of it in the floor plan. Fine. This particular door, I'll just change this material to sash copy, or not sash. And just click this and look at the material part. Yes, the same material. Just paste, paste, and paste. Okay, all the instance parameters. Okay, now let me just close, and where is the ventilation here? Here it is. The washroom part is here. So WN and the lower windows 2 cross 2, and just place it with plinth level and to 6 feet. Yes, fine. So okay. Now here DR again, entrance door. So where is that entrance door? Yeah, this is it, I guess. Yes. Just host it this particular wall. Yes, and just select it and change all the material. Copy, paste, paste, paste. Oh, one more remaining. All these are parametric doors, openings designed by me. Fine. If you want to get to the concept of this, fundamentals of this, and how to design this parametric openings, these are not provided by Revit library, and you have to enroll for this course and learn that. This is going to be the fixed window 1, 2, both having cell of cell height 15 inches. Yes. Then we will have DR, that sliding folding door window. Type A. Oh, that's too huge. Type B, I guess. Yes. This will just take a bit of time to regenerate since that file is very heavy. That particular family is very heavy, but it will be placed, so you don't need to worry. You just need to shift it a bit so that it doesn't have a conflict with the wall. Okay, so that is done. Now here we will design a curtain wall. That would be later. Right now, let me just go for windows and this casement and awning window. Where is it? Yeah, here it is. Window with side light and transom. Casement window. One. And it will be here. Since I know it. WN and this particular window will be hosted here. Kitchen window. Okay, and both of this window will have the cell height of 15 inches as well. Yes, location, I will just adjust it roughly right now. Oh, so see, it's conflicting with the wall. Okay, fine. And this particular window will have sill height of 3 foot. This kitchen area is there. Okay, and CS, but I will just go to category A and post that here. Again, it will take a bit of time to regenerate. Just stay tuned. Okay, and just shift it a bit. Let's open up this awning encasement window. So 45 and 35. Yes. And let's get rid of the sunshade because it's already covered. So sunshade. Same way, get rid of source and shade and awning encasement window 45 and 45. Okay, shift it a bit. And yes. Next is what? What is next? Yeah. Here there will be WN and that sliding window. Where is it? Come on. Don't tell me that I forgot to load. It should be there. No? Let's just go to the particular project. Edit family. Double door sliding. Load into project. Not sliding window. Yes, that was door, not a window. So yes, double slope, double sliding. Just post it here. Okay. And what else? So here there are ventilations, but where are those? You just check. Oh, those are on this wall. Just go to this particular wall and WN and look for that 2x2 one and say that 6 foot. Copy to clipboard, align to selected levels and paste it to length level. Yes. Okay. WN and that box window. Yes. One is this, which will be, let's see that where is this? Oh, yeah, here it is. One and two. Both of this. To say that level varies, yeah, that's fine, but the cell height should be 15 inches. CS, another type of that. One and two. One and two. Say that cell height 15 inches. Okay, perfect. Matches. It does matches. We will have the ventilation here and here. So CS, put one here and put one on this wall. Okay, and that should be 6 feet. And this should be 6 feet as well. Okay. What window do we have here? Yes, so we don't have any windows over here, but we have a cutout at 6 feet. So that I'll just show you that how to create such corner windows just in a while. Just stay tuned. Let me just switch to this option, straight roof option. Okay, yeah, right. So everything is done. Now we need to create this cutouts, okay, in order to place this particular curtain wall, which is going from bottom to top. Okay, so just try to follow. No, just go to plinth level. Yes, and we'll create a cutout over here. So say that architecture and where is it? Wall cutout. place it and drag it. CS, place it and drag it. Drag it till where? Till this particular point. Okay. I hope I'm not messing up. Now here we have this slit. So this would only be somewhere over here. Not important, you can adjust it later according to your design. Okay, this to here. Fine. Let's go to 3D. Okay. That cutout should have the top offset of -2 feet, with base offset of 6 inch at this level, because you might happen to go out. You might provide a door in the curtain wall. So select both of these cutouts, copy to clipboard, and top offset is -2 feet. Yeah, that's fine. -1 feet and 6 inches. Be important. So copy to clipboard, align to selected levels and to first floor and terrace level. Okay. Yeah, you cannot copy these cutouts in order to place it. Just delete them. You cannot copy the cutouts, you have to place it individually. Fine. So I guess that it should copy. Copied, but I don't know why is it not cutting the wall. Let's go to first floor. Yeah, it should cut the wall, not because it's copied. Okay, fine. Let's not waste time and let me just go to the wall, create a cutout here. Two of them and create it. Sorry. CS and okay, and also let's place them at terrace plan. Okay. Also, yeah. Okay. Now we will go to 3D and match all of them. While let's first select all of this and give them a seal height base offset of 9 inch and top offset of -1 feet 6 inches. Okay, now just go to this particular right elevation and match H12. It will automatically snap to the lines, I guess. Yes. If not, then draw a reference plane. Draw a reference plane in this elevation. So since it's the right elevation, so you need to go to north, east, south, west elevation. Oh, sorry, east elevation. Here you can draw a reference plane and just make them snap to it. This is again tricky. Let's say that its dimension is given in this particular 8.4, so let's make it 9 foot. And so let's just move it a bit, and then let's say that 9 foot 9. No. See, so sometimes this really creates a problem. Let's just roughly snap it right now. Get into, because anyways we are going to design a curtain wall on top of that. So let's go to west elevation. No, northeast. Which elevation is this? So see here, there's nothing. Here, this thing. Okay, right. Now we have to design a curtain wall here, but before that, also let me just shift this particular, go to plinth level and copy that, from here to here. But let's say that this will only be 1 foot or 2 feet. How much it is? Yes, 2 feet. Let's keep it 2 feet and go to 3D and then say that copy to clipboard. This would not work, I guess. We have to design it differently only. Okay, let's try. Just cut the wall with this. No, see, it's not working. Join geometry. No, it's not. So we will have to go to this particular plan. CEO, copy this, and same way terrace level. CEO, copy this, and now go to west or east. Yeah, and just adjust it roughly to match the profile, the alignment of the profile. Just adjust it to match the alignment. Yes, okay. Okay, but here and here, I guess that minus 1 foot 6.5. Yes, okay. So that is how you have created the cuts, opening cuts in the wall. Fine. Now you have to design a curtain wall onto this particular thing exactly like this. Exactly like this. Okay. So let me just check once before placing that curtain wall. System is empty. Yeah, it's the 3 horizontal millions. Okay. Where is its location in plan? Hmm. Okay, let's add it. Go to plinth level and say that WA and look for curtain wall. Rename it, calling it duplicate. Curtain wall, curtain wall courtyard. Courtyard. And just say that okay. And the plinth offset should be 16 and all the way till slab top. One top offset minus 1 foot 6 inches. And draw it from this point, space, press space, this point to this point. Okay. Now, what you need to do, you need to select that curtain wall and say that the curtain panel should be empty. Since we are going to host mullions onto that, So where is it? Empty. Yes, curtain panel system. Empty. Apply and OK. Right? So this is now just a piece of. So what you can do? You can select both of that curtain wall and this curtain wall. I guess that this should be snapped only till this point. Go to 3D, and with that selected, just go to edit type, and here layout. Vertical grid should be none, but the horizontal grid should be at the fixed distance of 3 inch from one another, and the horizontal mullions should be this rectangular mullion 1.5 cross 2.5. Apply and OK. Beautiful. Okay, understood. And now with this, I'll just select one mullion, just one mullion, and go to family type, and let's just select it, edit type, not family type, edit type, and just change this material to sash. Apply and OK. Fine. But it's getting inserted in the wall, so we need to bring it outside. So again, go to edit type, and width on one side should be, no, thickness is 2.5. That's okay. Width on one side should be 0. I guess. No, let's go undo. Let's see it in plan. Where are the mullions now? Okay, so just select all of them, move. Yes, but you cannot move it. You have adjust this parameter. So it's 2.5. Yes, the 2.5 from center. So let's try to move this curtain wall a bit, and this curtain wall. This curtain wall. Move it from this point to this point. And yes, with that, okay. Yes, perfect. Okay, no issues. See, here I guess that this particular thing has not yet been moved. It has moved here, but on the topmost floor it has not. How is it possible the curtain wall is continuous? Let's go to the rest plan. And yeah, perfect. What is the issue? Yeah, fine. This alignment in the plan was lost. Okay, so this is how you create this particular curtain wall. Fine. And now we need to create a curtain wall, a piece of glass over here. Fine. So that would be again going to plinth level. I would say that CS and say that edit type and duplicate this and call this curtain wall courtyard slit. Okay. This wouldn't be system panel empty, but this should be system panel glazed. Okay. And we'll don't have any mullions, none, and none. Apply and OK. And just with the top offset of 6 inch and flat top -3, it's perfect. Just snap it from this point to this point. Just move it. We already created a cut, so there's no point moving it. Only thing is that select this, unpin this, and edit type and call it duplicate glazed for courtyard slit. Courtyard slit. Don't forget this step, otherwise you will end up wherever you will have a reference this particular glaze panel, it will create an error. Fine. So with this, just go to 3D. Fine, absolutely perfect, no issues. And what we just need to do, go to architecture and mullion and 1, 2, 3. Let's say why I paste origin. Still guess that this should be 40 split and move it. No, we have to move this particular system panel. Move it from this point to this point. Yes, that's right. Perfect. Okay. No issues. And just go to 3D. And yes, now it is perfect. Say that mullion and all grids. And with that all grid selected, there's 2.5 cross 5. The one that we referenced here with the material cost, that is 1.5 cross 2 cross 7. And with all grids, just right. Okay. Perfect. Here, I guess that because of the opening cut, which is less here, I guess I need to go to terrace plan. So this is the importance of adjusting the opening. If you don't adjust the opening properly, then you might, but right now I'm not going to waste time on them. Okay. Okay. Here to start lens level. Let me just take this a bit somewhere over here. Yes, fine. Okay. The same way, this particular slit will be created. This particular slit here at this end. This particular slit, same way that will be created. Let me check that what is the base offset. 15 inches and minus 1 feet 7.5 inches. Okay. So I'll just go to terrace plan again. No terrace plan, sorry. Plains level. Select this opening cut and CS. And with that, we'll just place it here, from here to here. And that would be just 2 feet. Okay. And height base offset would be 15 inches. And minus top offset would be 1 foot 6.5 inches. Okay. And the same we have to put here. So again say that CS and yes, and that should be 2 feet as well. And base offset 15 inches and top offset minus 1 foot 6.5. Okay, but we need to check the alignment of that. So let me just draw a reference plane over here and over here. And let's go to which elevation would be this south elevation. South elevation. And yes, so see, let me move this reference plane here and drag this to snap to those reference lines. Perfect. Okay. And this also let me get rid of this distortion shade, but we are going to have an elevation treatment on this particular wall. Fine. Sill height is 15 inches for this window, I guess. Yes, the lintel will match. Okay. And what will come in? Give the sill height for this window. Get rid of sunshade and yes, 15 inches. So get rid of distortion shade. Fine, 15 inches so the lintel will match. Okay. Now let's go to 3D again. And herein, base offset is minus 1 feet 1 feet 6 inches. Minus 1 feet 6.5. Yeah. Okay. And with that, we can use the same curtain wall, the slit, 40-yard wall slit, and CS. We go to plinth level and create it from this end to this end. Yes. From here to here. Plus, snap it. Just select this and pin. Move it from this point to this point. Why is it not moving? Oh yes, so we need to select this part. Okay. And then move it from this point to this point. Right? So with that, going to 3D, slab softening. In this case, it will be terrace plan. Perfect. Okay. HI and just go to connection and mullion, and with all grids selected, just snap. Okay. HR. Perfect. Now, the most difficult part of this would be this corner window, but that we will see last. First is that I will need to create this vertical curtain wall here and also here, this particular curtain wall. Okay, so let's again check simple curtain wall. Yeah, glaze 2. We don't have any. Yes, so this is going to be very simple. Issues with that. The only thing that we need to check the parameter of this. Okay, again we'll have the opening cuts here and then we'll have to place the curtain wall. Fine, both of this will quickly create. So first floor, HL, and hide this first floor. Don't want to see what is happening below. Just change it to ground level. Sorry, change it to none. Okay, and WA wall and curtain wall. One, duplicate it and call it, but this is just going to be customized, so we don't need to duplicate it. Fine. So we will have duplicate. Curtain wall, first floor, or let's say that curtain wall terrace area. Mhm. First floor, terrace is above. Okay, and just lay that particular curtain wall from here to here, but I forgot to check automatically embed. Apply and OK. Create that from here to here. Okay, just pick the direction. With that selected, just go to 3D and say that HI, that is isolated. And real quick, go to grid and create one in the center, 2 9 from here and 2 9 from here, and some unequal distribution. Yes, and put in grid from top 7 foot pencil, and we will get rid of this. Okay, and I would say that mullion and the same mullion, all grids, and just snap it. Okay, delete and delete. Go to insert, load family, US, and curtain wall doors, DR. Oh, sorry, load family and furniture, not furniture, sorry. RVT libraries, English Imperial, US, and doors, and curtain wall door. This is it, or this is no, this. Okay. With that loaded, just press tab until you select the system panel list, have a drop down, and just select this particular door and just change this to fine. And you'll be able to see the handles. And just go to this and change the material to sash. Copy and paste. Apply and OK. H bar. Perfect. Right? And you can have your divisions accordingly the way you want. I have created this equal division. Fine. Now we need to create the opening cut over here as well. So I'll just press H, select this cut, CS, and here, and just drag it. I'm working in 3D. Just drag it, and this should have a base offset of 15 inch, or let's say since it's a ground floor level, so 2 feet, and top offset should be -1 feet, 7.5. Okay. Go to plinth level. Yes, and adjust section plan. Same, this particular same thing will have CS and go to first floor. Select this wall, just drag it. Again, top of base offset in this case should be 6 inches, and top offset minus 1 feet, 7.5 or 6.5. Important. Go to terrace level, CS, and go to terrace plan. And first floor CS, go to terrace plan, select this and just draw it. Again, say that -1, -6, top offset should be -1 feet, 7.5 inch, and base offset should be 15 inch. What was the base offset in this case? Or not 6 inch, 15 inch. Okay, let's see it in 3D. Okay, your beams are not getting cut anywhere. Fine. If you just drag this particular opening cut a bit down, then you'll see your structure will be visible. So to do that particular thing, and just go to left elevation and roughly adjust it. Yes, HL and yes, this to this to this, HL, R enter. Yes, fine. That's perfect. Okay. Now design a curtain wall for that. So architecture and WA, edit type and duplicate it, call it curtain wall, stair cabin. Okay, and again we are going to just place from here to here, but this time, yeah, from here to here, and this would change to courtyard slits with wood, and just shift it from here to here. Yes, okay, perfect. But why can't we see that? Oh, yes. So again, we need to give it a height offset of 2 feet, and the top offset should be terrace plan -1 feet 6 inches, or -1 feet 7.5. Not terrace plan, slab. Okay. So only thing is that HI. If you want to change the color of this particular glass, make it appear dark glass, then just click this, edit type, duplicate this, and call it glazed for stair cabin. Okay, and the glass material should be not the simple clear glass, but we'll say that dark. Already defined that material, dark glass. Fine. So just select it, apply, and OK. Fine. So this glass appears dark now. And with that, just HR. This we cannot do without this particular reference because you need to follow this beam profile. So what I will do, I'll just go to west elevation, HR, WF, east elevation, south, कर रहा हूँ यार, north, new elevation, HR, hidden line. Yes, so this is that same view category. Okay, H, and yes. So we need to follow the, but this would be much better, not in elevation, but because if I turn it to wireframe, then you will have a see-through and will not be able to snap to the lines. So what I need to do, I need to go to plinth level, And herein, I'll just create a section over here. Which section is that? I'll just bring this particular view range only up to this point. Okay, and go to this particular section and then turn it to wireframe so we can see the beam profile. But then too it will be very difficult to visualize. How to do this? We'll have to do it in 3D only. And yes, let's just try hide in view by category. Okay, and just say that architecture and curtain grid. And yeah, sure. Oh yes, in 3D only we should have done a 1 and 2. Yes, 1 and 2. And let's hide this door. And yes, here we don't want. And verticals, we can create whatever we want. We just need to control this. So this, I guess that should be 0. Okay, no. And did it read the grid line? No. Perfect. Yes, all the grid lines are perfect. HI. And the vertical grids, you can just keep it according to overlapping grid line should be avoided. No. Just ignore that. Okay. Okay. And okay. Fine. With this HR and R enter, it is realistic. I have entered that particular shortcut so I can use that. You need to enter that while going to this view user interface and this keyboard shortcuts. यहाँ से कर सकते हो. Fine. I will just go to this particular architecture and mullions, all grids, and with that 1.5 to 2 cross 5, I'll just paste it. Perfect. Fine. So the same way you have to create a slit over here. So now is the most difficult part of this tutorial, that how to create a slit corner window, which is this where is that particular my project. I just close this unnecessary views, save it before I lose it anything. And now the most difficult part of this particular entire exercise is creating this corner window without the mullions. Fine. So we will do it. I'll just show you that how to do that particular thing, and this is also a little bit tricky. So I'll just go to this particular planes level plan, and herein I will create WA and curtain wall 1 and duplicate it again, calling it corner curtain wall corner. Right? And with that, what I will do is that first I will snap here and then I'll snap here. Both of that I will select and say that automatically embed checked on. Okay, both of this should have a base offset of, let's say, 15 inches and top offset of minus first. Yeah, perfect. Okay, but then now how to create this, get rid of this particular thing. So one way is that you can just select this particular thing, this particular wall, this wall, outside wall, and just go to edit profile, HL, HL, HL. Fine. And with that, what you can do is that, this has created the, yes, this wall, I guess. Yeah, fine. Edit profile and then HL, and then snap to this and this. Okay, TR, join this to this, finish. And just like that, you have to edit this profile. Snap to lines 1, 2, TR, and join this to this. Oh, sorry. Yes, yeah, it was fine. And join this to this. Get this external. He's got to snap to one line. TR, and join this to this. And mm-hmm. And finish. Okay. Enter. And you have your corner window. But still, there is a problem. What is the problem? That you don't have a flush surface. Fine, you don't have a flush surface. So how to do that? How to do that particular thing? This should be snapped here. Yes. How to do this particular thing? So in order to do that, what we need to do is that first we need to make this particular two thing intersect. Fine, and then when I might not get it with one go, TR and join this TR. I might struggle to get it perfectly. Yes, so yeah, done. See, you have a flush joint, right? But if I just drag this over here, yeah, that would look much better, right? So this is how you create the corner window in Revit. Okay, just change this particular thing to glazed for stair cabin, black glass, and this too glazed for stair cabin. Right, but with that, this will again lose its connection. And when you end up in such situation, what you should do is that WA and go to wall, because this is difficult to join. This won't join. I just say that TR and yeah, this won't join. So WA and select any one wall, existing one wall. Let's select this particular generic 6 inches. Edit type and duplicate it, call it glass wall. Okay, the glass wall is already in use. Yeah, fine. I had copied that from that particular project. So with that selected, just press tab until you find this curtain wall. Press tab again, select this, and just drop down, and you have this black, what do we say, glass wall. Yes, and just you have clean joint. Okay, so this is nothing but just a wall. See, this is nothing but this is just a wall which has been given a thickness of 1 inch and that material glass dark glaze. So this is a trick. This is how to trick Revit, right? In order to get the thing fine. So this is the way you have created the corner window, fine. And just like that, you will have that particular same corner window here. And where else? Here is the straight wall, so that's fine. Here, yeah, fine. This particular glass wall, right? Clear? So let me just go to this particular plane line again. What is left now? What is left here? Elevation treatment. You need to create this particular elevation treatments on both the end, and that would be really very easy. Fine. So I'll just show you real quick that how to create such elevation treatments. So plinth level and RP reference plane, and I need to draw two reference plane on the first floor. RP, one over here and one over here, right? And take this particular section here and flip it, and then I see this face of wall. Take this section and flip it until I see this surface. Okay, and then I'll just go to architecture, component, model in place, and since it is going to be elevation treatment, it should be a category of wall, and just say that elevation treatment. Okay, and with that set plane, pick a plane, pick this particular plane and go to section 2, right? Here we are. So now we need to create that particular thing. So extrusion, and I will just create a simple extrusion, snapping to this, taking the reference of this particular window. I will drag this here. Then what I will do, since it's going to be a 2 feet, so from here I will just extend it 2 feet. How much is this? 1 feet 6 inches. So yeah, let's say be 15 inches. 15 inches is enough. So just move it 15 inches. TR, join this to this and this to this. Okay. And what is the profile? Yeah. Okay. So go to section 2. And then I'm just going to create a couple of wide extrusions. So create. And first I guess that I need to finish this. So 15 inches should be the extrusion. No, but I want to create the void as well. So let's draft it out. So CO and 6 inch down, offset it 6 inches and 6 inch from here. PR and join this to this and this to this. Okay, and with that, just copy it multiple times. 1, 2, 3, 4, 5, and 6. Okay, and with that, just select this and roughly adjust it to make an equidistance. Yeah, fine. And from that, just delete all this. Yeah, fine. There are no lines. So just trim 1, 2, 3. Am I trimming the correct part? Yes, 1, 2, 1, 2, and 3. 1, 2, and yes. Split element 1, 2, 3, and 4. Perfect. And yes. Okay. And just copy this CO and just finish it. Okay. Let's go to 3D. I guess that minus 1 feet 3 inches. Okay. And I'll just give it a material elevation, or let's south wall. What was the material? I just forgot it. Let me check. Material has been copied, so we just need to find it. Otherwise, we already have it there. Textured wall. Yes. Copy. And just go to this particular 3D. Just give that material, same, paste, textured wall. Fine. Okay, now we need to create that same component here. Fine. So what I'll do, I'll just go to plinth level, and this time I'm just going to say that Cad plane, pick a plane, click this and go to section 1. Right? And roughly I will just create that same extrusion from here to somewhere over here. Okay. Yes. Okay. And I will say that offset or Y offset. We already have this offset 6 inches here, and then just pick this line, snap 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Just join this to this, this to, we need to create, we need to cut this at various segments. Okay, and just join this to this. Here and join this to, or let's use another way. Just copy this particular element, CO, copy it from this end, this end, this end, this end, this end, and this end. Okay, there's a better way of doing it. And just delete this lines, construction lines, and then just TR, because we have splitted the lines, so we just need to join them. And yes, okay, fine, and just finish. Go to 3D. What we just need to do, give it the same material textured wall and just join this to this. Okay, and your elevation treatment is done. Only thing is that it is extruding too much. I think that 9 inches is enough. It's -9 in this case. We need to snap, yeah, all the lines, all the elements we need to snap. 1, 2, 3, 4, 5, 6, and 7. Okay, with that we have created this particular thing. Fine, we need to add, but before that, let me just complete this as well. This is really easy. And what is on this face? So RP, and I will just draw a reference plane here. Okay, for that I'll just finish off this model and take this particular section here and flip the direction. Again, go to that same element, 3D, and select this and put it in place, and go to plinth level. First floor भी चलेगा, plinth level or first floor, pick a plane and pick this vertical plane and go to section 1. And you need to create the elevation treatment here, so just say that extrusion and create one. Okay, and we need to get rid of this. Let's not do this. Okay, and just get rid of this. Get rid of this, and I guess that will be here. Okay, and let's create a couple of random circles. What else? Here also there should be one. Okay, so let's come into this section and draw one line, offset it 6 inches, and offset it, array, offset 6 inches here as well. Here and join these to this. Fine. What we are going to do is that copy it and move it exactly 1 feet. Fine, and then copy it multiple times from here to here, 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 and let's do some smart work. Copy, yes, move it, move it from here to, and these are the drafting skills. No rocket science in that. Copy from this to this. Okay, and that's enough, I guess. Only one to any one, I guess. CEO, and yes, you can adjust the CEO here. Fine. And what I'm going to do, split element 1, 2, 3, 4, 5, 6. Let me just see whether we are going correct. 1, 2, 1, and 2. From here, we again need to have split lines. So split 1, 2, 3, 4, 5. With them. Oh, no, not them. Okay. Join it from the point where we left. Oh. Drafting work. Here, that would be one problem. So just CEO and copy this line from here to here. This to this, and split line. Copy and paste this. Join this to this. And no, it shouldn't be there. Okay, perfect. And extrusion start 0 and extrusion end 18 inches. And the same material, paste textured wall, and just finish. Go to 3D, and yes, fine. So that particular thing has been created beautifully. So with this I finish, and what left is just to add ventilations over here. That would be really easy. I'll go to terrace plan of first floor, terrace plan of first floor, ceiling plan of first floor, terrace plan named ceiling plan of first floor, and yes, ceiling plan of first floor. And here is that particular split. So I'll say that wall, just create a simple, that's the curtain wall, existing curtain wall. कोई भी select कर लो, just select this particular curtain wall. Curtain wall 1, just edit that, automatically embed checked, okay. With the base offset to 6 foot in this case, and top offset to minus 1 feet 6 inches. Yeah, that was correct. No, but that would make its unconnected height 2 feet. So let's it be 6 feet 6 inches. And just drop from here to here. Yeah, you cannot see it because the ceiling, the view range of this is 9 feet. Just bring it to 7 feet and cut plane to 7 feet as well. Okay, and you see that we have created that particular slit. Okay, and we just need to control its length here, 3D, and select it and copy to clipboard, align to selected level and to ground floor or plinth level. Yeah, plinth level. Fine, and just say that select both of that 1 and 2 and just HI architecture and mullions, all grids 1 and 2, and you are done. Right? Clear? And the same way I created this particular thing here, you need to create here. Fine. So we will do that quickly as well. So this is that face. So let's select this particular. No, this time we need to select this curtain wall corner one, and yeah, height is perfect. One and two. Okay, just need to trim this all the way. This system panel glazed. Select both of that and change it to glass wall. Where is that glass wall? Two. Yes. With that, this is going to create a problem for me. Let me just click undo, and before making it the walls, what I need to do is that I need to trim that. I need to make it join here. Um, okay, let me just select this and say that let's change this offset 0. Okay, and then once that done, now you need to 1 and 2 and make it equals glass wall. Glass wall 2. Fine. But that also does not working. Okay, I need to check this particular thing. I'll update you once it should work. I don't know why it does not. Right now, let's just not waste time on this. Okay, we created this, but I don't know why this is not getting created. Might be some glitch or error. Okay. Now, what you need to create is the columns over here and then the pathway, shaded pathway. But that is really very easy, and you just need to create a curtain wall. See, I'll just show you it here itself in this particular thing. So these are the columns. Just finish it. And select this and H8. Okay. So these are the columns. Ground floor to first floor with -6 offset, 6 inch offset, and then this is the model in place that has been created, and it is nothing but an extrusion, a simple extrusion, -6 inch start and -6 5 inch. So there is 1 inch of extrusion just to define the base of this particular thing, and then we have this particular curtain wall resting on it, which is the same curtain wall we created this particular thing, this particular curtain wall. See, with system panel empty and with the fixed distance of 3 inch. So just like that, this particular thing is sloped glazing. Just like we have curtain wall for wall function for roof, we also have this slope glazing. Where is it? Yeah. Whenever you draw any of the roof, then you have an option to select this particular slope glazing, and that would exactly work like a curtain wall. Fine. So this particular slope glazing, if I just go to edit type, then you see that the layout is fixed distance 1 feet and the grid type, grid 1 mullion, is rectangular 2.5 cross 5. Okay, and this is 2.5 as grid 2 is also 2.5 cross 5. Okay, and the fixed distance of grid 1 is defined, but for grid 2 there is no so this doesn't make any sense. Fine. Okay, only the what is grid 1? Grid 1 is, yeah, so that's grid 1. Okay, so okay, apply and okay. Fine. So that is how we have defined this particular way. Okay, so that was pertaining to the 3D interface, that is the 3D modeling with perfect precision and perfect joint condition with interference report, that is the clash detection, to be 0. Fine. And now you can add human figures and trees and all that. And that is really very easy. Just go to insert and load family, and under this US, you have this enter age, wherein you have this beetle, then you have male, female, all that, truck, van, okay. And if you want to add trees, then you just go to component and place a component, and there are lots and lots of existing trees defined over here. But I don't think that Revit is a rendering engine. Instead, you can have much better rendered views in Enscape, which you just saw in the introduction, the walkthrough. Okay. So this was pertaining to 3D interface. Now, if you want to get to the 2D part of this, the 2D part of this, which I explained in the, I did this hide in view by category in skip element. So the 2D part, which I explained in my introduction, 15 minutes of introduction. So that is again a real big topic. So if you want to get the fundamentals and basics of this, then just enroll for this particular course and let's learn together and let's grow together. And as I said, the next batch of this particular course, Revit BIM, which is the combo of architecture plus structure plus MP, is starting on 14th of March. That is Thursday. Yes, next Thursday. Fine. So just enroll for this course. Let's meet one on one and let's learn together and let's grow together. So bye and just enjoy the tutorial.